Hello everyone, I hope you all are doing well and welcome to the Docker Crash Course. My name is Dheeraj and I will be guiding you through this Docker Crash Course tutorial. Whether you are new to containers or looking to deepen your knowledge, this crash course will give you practical insights to get started. So we have got a comprehensive agenda covering everything you need to master Docker, starting with the fundamentals like introduction and setup to get everyone on the same page where you have Docker installed on your machine. Then we will deep dive into the architecture so you understand how Docker actually works under the hood. Then we will cover essential commands that you will use in your day-to-day activity while you are working as a DevOps engineer. Then we will get into Docker files and understand the best practices for building the Docker files efficiently. Then we will explore the full life cycle of Docker images and how to create and manage the images for Docker. Then we will deep dive into volumes, understanding what is persistent data storage and how it is getting associated with your Docker container. Then we will cover networking so your containers can communicate properly between each other. Then we will look at the Docker Compose, which is going to help us for orchestrating multiple container applications, where multiple container applications would be talking with themselves under one network using Docker Compose. Then we will discuss secrets and configuration management for security. And we will wrap up with the health checks and reliability patterns that you would be using in your production environments. So by the end, you will have the knowledge to build, deploy, and manage Docker containers confidently. So without wasting much time, let's get started.
Let me explain Docker with a simple analogy. You know how shipping revolutionized the global trade with standardized containers, right? Docker does the same for your softwares. It packages your application along with everything it needs to run, like the code, runtime, libraries, system tools, and configurations, into a single unit called a container. This container runs exactly the same way, whether it's on your laptop, your colleague's computer, a test server, or in your production environment onto the cloud. There are no surprises, no compatibility issues. Docker is open source, which means it's free to use and has massive community contributing to it. This makes it incredibly powerful and well supported. So, what exactly is a container? Imagine an apartment building. Each apartment is self contained with its own kitchen, bathroom, and a living space. Residents in apartment 5A don't interfere with those in 5B. But all apartments share the same building's foundation, plumbing infrastructure, and electricity supply. Container works the same way. Each container is an isolated environment running your application with its own file system, processes, and network. But all containers on your machine share the same operating system kernel, which makes them incredibly lightweight. A container can start in just few seconds compared to minutes for a virtual machine. This efficiency is what which makes Docker so powerful. You can run dozens of containers on a single machine without slowing it down. So many people ask, how is Docker different from the virtual machines? That's a great question. Many times you get asked these kinds of questions in your interview too. So let's decode this, that what is the difference. So on the screen you can see I have two images. One is virtual machine and the another one is the Docker container. So virtual machines include an entire operating system. Like, imagine copying Windows or Linux for each application. This makes virtual machines huge, often several gigabytes, and they take minutes to boot. They are like having separate physical computers. But on the other hand, Docker containers share the host operating system's kernel. They include your application and its direct dependency. This makes them tiny, often just megabytes instead of gigabytes compared to the virtual machines. And they start in seconds. Think of the virtual machines as separate house, each with its own foundation, own plumbing, and electrical systems. But on the other hand, containers are like apartment sharing the same building infrastructure. same foundation and same plumbing. So both provides isolation, but containers do it much more efficiently. You can run 10 to 20 computer containers on a laptop that might struggle when you do the same with virtual machine, because whenever you are creating the virtual machine, there comes the hypervisor. For each and every virtual machine you will have to create the hypervisor. But on the other hand, if you see from the hardware perspective, instead of having the hypervisor, you directly have the container and the host OS on which you want to run your container, instead of just running the virtual machine with hypervisor and the host operating system. So let's talk about the real problem Docker solves, why it is so famous. First, the infamous thing, it works on my machine problem. How many times have developers said this when code breaks in your production while they are working? Docker eliminates this because the container that works on your laptop is identical to what runs in your production system. Second is the dependency hell. Imagine working on two projects. One needs Python 2.7 and the other needs Python 3.9. Installing both causes conflict on the same machine. With Docker, each project runs its own container with its own Python version. So it resolves that conflict. Third, onboarding a new team member. Traditionally, this takes days of setting up environments. With Docker, just share the container, they are productive in minutes without wasting any time. Docker also enables microservices architecture where different parts of your application can run independently. It's essential for modern DevOps practices, making deployment smooth and reliable. And compared to virtual machines, it's incredibly cost effective because you can run more application on the same hardware. Now let's get Docker installed for your machine. So there are multiple ways of installing Docker. So if you are doing it for Windows, you can install it using docker.com. If you are doing it on Linux, you can install it by using uh, these commands. And once you have installed by any of the method, you can go ahead and check by running Docker version or just Docker. Because when you run Docker, it will give you whether it will show you whether Docker is installed or not. So for Windows and Mac, from docker.com, you get a downloadable, but you can also use brew command to install it. So as I have a Windows machine, so I would be doing it on Windows. And so now to install Docker on our local machine, I will just search with the keyword Docker. Once I do that, I can go ahead and install Docker on my machine. So for doing that, what you can do is you can just click on Docker desktop. Once you are inside Docker desktop, over here you can search for Docker desktop and you are inside this page. So from here you can download the Docker desktop. That is one of the way. But if you are on uh, Windows, you can also install it from Microsoft Store. So let me show you that too. So now I'm opening the Microsoft Store. So once you are inside the Microsoft Store, you can just go ahead and search for Docker desktop, and you can see the Docker desktop is available over here for you to install. So you can just go ahead and install it from here too. So I will just click on install and the Docker desktop is getting installed for me. So this should take around 4 to 5 minutes for it to get installed on your local machine. So it's installed successfully and now it is going ahead and installing it. So while installing, it is going to ask you, do you want to give permission for this app to be installed? So I have given the permission and now it is just going ahead and installing on my system. So once it's successfully installed, you can just go ahead and click on open and it should launch your Docker desktop for you. And this is how your Docker desktop is going to look. So over here, Either you can log in with your email address if you have a Docker account. If not, you can just skip it for now. So I'm just going to skip it instead of having an account for it. So now I have skipped it and now it is going ahead and starting my Docker engine. So once my Docker engine is started, then I will just go ahead and run the command Docker version. So right now, this is going to be your Docker desktop. So later on, I will show you once we create the Docker Hub account, how we are going to associate that with this Docker desktop. But these are the available options which are over here, which shows the containers, images, volumes. If you have Kubernetes, the builds that you have made, everything is going to be part of this Docker desktop. Now, let me take you to the command prompt. So now, once I'm in the command prompt, the only thing I have to do is I can do Docker hyphen hyphen version, which will show me that, see, this is the current Docker version which has been installed on my machine. And you can also use the command Docker, enter, and see if you get this kind of output, which shows that what all commands are available in Docker and everything. That also means that your Docker is successfully installed on your machine. Now, time for the exciting thing. So if you want to really see that the Docker is up and running and it can host the containers, so you can do a small testing by just running this command, docker run hello world. So I will just go ahead and run this command for you. So I'll clear the screen and say docker run hello world. So So this is how, when I ran this command, it was not able to find the image on my machine because it was not installed. So it went ahead, it grabbed the image, installed it on my, downloaded that on my machine, and based on that, it ran the container for me. Now, if I take you to the Docker desktop over here, see in containers, you can see one container is available over here. So it last started, and this is the container name that we went ahead, and this is the image name that it installed, and this is the container name which worked. So this is how you can see how your Docker goes ahead and create the container. Let's start with the big picture. Docker uses a client server architecture, which means it splits into parts that talk to each other. When you type a Docker command like docker run, you are using the Docker client. This is the command line interface that we saw. Command line interface is nothing but this thing. So this is, suppose if I say docker run hyphen hyphen help. So whatever C commands that you're going to run over here by using docker run. So what is this? This is nothing but the Docker client. So this client actually doesn't do the actual work. It sends your request to the Docker daemon. Okay, so which is a background service constantly running on your machine. So the daemon is the brain. It builds the images, runs the container, manages the network, and handles everything for you. And finally, next comes the Docker registry. It's like the Docker Hub, which stores images that you can download and share. Think of it like a restaurant. You are the customer. The Docker client is the waiter taking your order. The Docker daemon is the kitchen preparing your food. And the Docker registry is the grocery store where ingredients come from. So this separation makes Docker flexible and very powerful. Let's talk about Docker images. This is a crucial concept. An image is essentially a blueprint or template for creating containers. Think of it like a recipe for baking a cake. The recipe tells you all the ingredients and steps required to create the cake, but it is not the cake itself. Similarly, a Docker image contains your application code, the runtime environment like Node.js or Python, along with all necessary libraries, system tools, and configurations. But it's not running, it's just an instruction. Images are read only and immutable, which means once you create an image, it doesn't change. If you need updates, you create a new version of that specific image. You cannot change the existing one. Images have a clever layered structure. Imagine stacking transparent sheets, each adding something new. This makes them efficient because layers can be shared between images. If you are a programmer, think of images as classes in object oriented programming. They define the structure. Containers is what we are going to discuss in the next one, which would be associated with this classes concept that I just told about. So now let's understand containers. So if an image is a blueprint, a container is the actual running application built from that blueprint. That is our image. When you execute Docker run command, Docker takes an image, creates a container from it. The container is where your application actually runs. It has its own isolated file system, running processes, and network interfaces. Here's something important. While images are read-only, containers have a writable layer on top. This means when your application create files or make changes, those happens in the container's writable layer, not in the original image. You can start, stop, restart, move, and delete containers freely. And here's the magic. From one image, you can create multiple containers. It's like having a pizza recipe. You can use the same recipe to make 10 different types of different pizzas. Each pizza is independent, but they all come from the same recipe. Similarly, you might run 5 containers of web application from one image to handle more traffic for your application. So now let's understand the key difference between images and containers. A Docker image is a blueprint or template. It's a static and read only, just sitting on your disk, as we discussed. A container is a running instance of that image, which is dynamic, dynamically executing processes, consuming memory on your machine. Images are like recipes that can be shared and reused. Containers are like actual meals you cook from those recipes. Each one is independent and isolated. So you can create an image once, but you can spin up many containers from it. Think about Microsoft Word. The installation files on your computer are like a Docker image. When you double click and Word opens, that running application window is like a container for you. You have one set of installation file, but you can open multiple Word files or Windows Words file from it whenever you require it. So each window is independent. Closing one doesn't affect the other. This image container relationship is the heart of Docker architecture, where consider images as a blueprint. You use it, and based on that blueprint, you can create multiple containers back to back based on your application requirements. And once you internalize this concept, everything else in Docker makes more sense for you. Now let's talk about Docker daemon, the real workhorse of Docker. The daemon is a background service that runs constantly on your machine. As soon as you install your Docker desktop, as soon as you start your Docker desktop, the first thing it does is it starts your Docker daemon. And when you install Docker desktop by default, so whenever your machine start, it is going to automatically start that. And this process, which runs in the background, is known as Docker D, and you usually don't see, but it's always there, listening and waiting for the Docker commands that you're going to run from the Docker CLI or make any actions from Docker desktop. And when you type command in the Docker client, you are not directly creating containers. You are sending instruction to the daemon, and the daemon does the actual work for you. Think of daemon as a factory manager. You send orders and the manager coordinates everything, like pulling images from warehouses, assembling containers on the factory floor, managing the factory resources, and keeping everything running smooth. The daemon handles building images from Docker files, creating containers, managing their life cycle like starting, stopping, restarting, and deleting them. It also manages networks so containers can talk to each other, and volumes for persistent storage they have. The daemon is powerful because it runs with elevated privileges and have direct access to the system resources, which is why it create isolated environment for your containers. Now let's talk about the Docker client, what directly it is and how it interacts in our day-to-day activities that we do. So when you open a terminal, you run a command docker run or docker build. So that is what is Docker client that you're using. But the client itself doesn't do the heavy lifting. It's just a translator. It takes your human friendly command, converts them into API call that the Docker daemon understands in the background process that is running. Think of client as your remote control and the daemon as your TV. You press a button on the remote, it sends a signal, and the TV does the work of changing the channels. This client can connect to a local daemon on your local machine or even a remote daemon on another servers, which is useful for managing production environments from your laptop. The client makes Docker easy to use. Instead of making complex API calls yourself, you just type simple commands like docker run nginx and the client handles the rest. Every Docker command you will learn follows this pattern. You use the client, it talks to the daemon, and the daemon makes the work done for you. Now let's talk about Docker images. So Docker images actually uh, live in Docker registries. A registry is essentially a storage and distribution system for Docker images like GitHub is for code or YouTube is for videos. The most popular registry is Docker Hub, the default public registry that Docker uses. When you run Docker run hello world, what it is going to do is Docker is going to automatically pull the image from Docker Hub. What is this Docker Hub? So let's go ahead and do it. So let me go ahead and clear this. And when I say Docker run hello world, so when I run this command, see what it says. Unable to find the image locally. That means this image is not there available on my machine. Then what it is going to do is pulling from a library hello world. So what is this pulling from library hello world? It is nothing but it is the Docker Hub from where it is pulling. Now what is Docker Hub? Let me show you. If you go on Google and search for Docker Hub, enter, and this is the container image library or registry where all the images are been stored. Now, let me go ahead and search for hello world. See, this is where the images came from. So when I typed hello world, so it pulled the image from Docker registry for you by default. And based on that, it spinned up a container. And when the container was spinned up, so this image was used and this was the name of the container, which we just ran 55 seconds before. So Docker Hub contains thousands of official images maintained by companies or maintains by the verified publisher or sponsors. Let me give an example. So let me go ahead and search for Python. Okay. So when I do that, you can see there are multiple images available over here. Now you might get confused that which images from what. So when I say Docker official images, so these are the official images hosted by Docker. When I say verified publisher, so these are the publisher who is publishing those images with their own product or with the changes that they are adding as part of that specific image. And when I say sponsored OSs, so these are the sponsored OSs which are available. So when you are using Docker Hub, you need to understand which kind of image you are going to use: official image, verified publisher, or sponsored OSs. Now, when I am searching for Docker official image, if you so as I'm searching for images, the first thing I will do is I will just click on images. So only images are available for us. And if I click on Docker official, then based on that, you can also see what kind of architectures you are looking forward for, and if it is for OS, Linux or Windows. So right now, if I say Linux, see, so this will reduce if so all are for Linux. But if I remove Linux and I say Windows, see, only these two images are available for Windows and the other were available for Linux. So that is how you can use Docker Hub and Docker Registry, by using which, yeah, you can go ahead and push your images that you have built locally, or you can also pull the images which are available as part of this Docker registry. So the first and foremost thing till now, if you have not created the account, click on sign up. Uh, Add your email. I will add my name over here, and I will add a password, and I will go ahead and sign up. So once you sign up, then you will have to use the same uh, username or password over here. Click continue, provide the password, and click continue. So once this is done, see, now my account has successfully been created, and based on this, now I can associate this to my Docker desktop too. So now if I go to my Docker desktop over here, see, it is asking me to sign in. So what I can do is I can actually go ahead and click on sign in, and it says open. So now, as I was already signed in on the browser, so it has automatically signed in, and now if I have been signed in from the same account that you can see over here. So now whatever images that I'm going to create on my local machine, I can go ahead and push it from there. Or if I am pulling any images, I would also have a track of it as part of my Docker hub that I have already created. So as part of this hub, you can explore whatever files and registries that you have, and you can get that associated with your Docker desktop. So let's start with the most important Docker command, Docker run. This is the command you will use constantly because it creates and starts your container. The basic syntax is very simple, Docker run followed by the image name. So let's take an example of Docker run Nginx. What it is going to do is it is going to start an Nginx web server for you. Here's what happens behind the scenes when you're going to run this command. First and foremost, Docker is going to check for image locally. If not, it will automatically download it from the Docker hub. Second, it is going to then go ahead and create a new container out of that image that is being created. So if it is locally available, it will pick from there. If not, go to Docker Hub, fetch from there. Then it is going to go ahead and create a new container for you. And just like that, you have a web server up and running. The beautiful thing about Docker Run is that it combines multiple actions into one single command, pulling the image if needed, creating the containers, and starting it for you. This simplicity is what makes Docker so powerful for developers. You don't need to install Nginx on your local machine, configure it, or worry about the dependency of having that Nginx on your local machine. One command and your container is up and running. So let's see what happens behind the scene when you really run it. So right now, if I take you to my Docker desktop, you can see right now we are in images. There is no image named Nginx. That means it is not going to find it locally. So it will do the entire life cycle. So I'm going to go ahead and say Docker run Nginx. Enter. See, unable to find image locally. So it is going ahead and pulling the image. Now it is downloading the image. The image is getting downloaded. Once the image is going to get downloaded, it is going to go ahead and start the container. So right now the container has been started. So let me take you back over here. You can see that Nginx image has been installed from Docker Hub. And if I take you to the containers, our container is available over here and it is up and running from 19 seconds. So over here, you can see that it is whenever right now the output that you're seeing because it is up and running and you can see that on the console and your console, that is your terminal, is logged now. In my next slide, I will tell you why exactly this happened. But for now, just focus on the life cycle that we spoke about. Check image locally, Docker Hub pulls if the image is not present, then create a container and starts the container. So now our container is started. So now let's talk more about Docker Run. So as I said, Docker Run is really powerful, but it becomes more powerful with options. The first option that you see on the screen is Docker Run -d Nginx. So it runs the container in detached mode, meaning it runs in the background and returns the control to your terminal. Without this, the container runs in the foregrounds and locks your terminal. that is what has happened over here. So over here, you can see my terminal is locked. The reason for that is it is running in the foreground instead of running in the background. So to do that, what you will have to do is, so I have exited this container. Okay. So if you go to the Docker over here, it is over here. This has been stopped. So this is the stopped container. Okay. If I say only show running container, see you won't see anything because it is not running right now. When it is running, it will show you in the green sign. So the container is stopped. Now I will run the same command for you. I will clear the screen, run the same command just with -d. But this time our terminal is not going to get locked. I'll hit enter. That's it. It gave me the container ID and my container is up and running. You can cross check that. It is going to create a brand new container again. If I go over here, see a new container is being created that you can see on Docker desktop. If it's green, that means it's running. If not, that means it is exited. So this is how you use the detached mode. Next comes the -p for port mapping. So when you run a web server in a container, it's isolated. So -p 8080 colon 80 maps your port 8080 of your local machine to the port 80 in the containers that you have just created. So you can access the web server at localhost colon 8080. So right now, what I'm going to do is I am going to go ahead and create another container over here for you. So this time, what we're going to do is we are going to go ahead and run the we will have it in the detached mode only. So let me keep the D as it is. And along with that, I will use -p and 8080 colon 80 Nginx. Okay. So I will go ahead and just hit enter over here and you can see one more container is been created. So if I go over here, you can see a new container has just been created and the port is visible over here, that is 8080. If I click on this port, you can see the Nginx server is up and running. So now I am accessing this port from my local machine 8080, but it is talking with our container on container port 80. This is how you use port mapping. Now let's go back to see our next option. So our next option is hyphen name. So this flag gives your container a friendly name instead of Docker's random names that you can see over here. So whatever name you can see over here, hungry, Makil, infallible, Meitner. So these are some unique names that it has created by itself. So if you don't want this kinds of unique name and a simple name based on your preference, so in that case, what you can do is you can go ahead and use -name over there. So for that, what I will do, I will go back over here. Let's create one more container. We will keep the other option as it is, and I will say hyphen. So let's keep it after 8080. So I will say hyphen name, and our name is going to be my nginx, and I will hit on enter and you can see the container has been created of the endpoint. Okay, so if I go back over here, yes, so the container has been created, but for some, okay, so it is in the creation phase, it is taking some time, but the container has been created successfully. That is how you can go ahead and add your custom names to the container that you have. Okay, so I will just go back to our screen, and for now let's talk about the next option. So the next option that you can see over here is Docker run IT Ubuntu bash. So what it is doing is the IT is for interactive mode that you can use when you want to interact with the container, like opening a bash shell in an Ubuntu container. So for doing this, what we can do is we can go ahead and clear our screen, and I would say Docker run hyphen IT, that is the interactive mode, and Ubuntu bash. So it is going to go ahead and take us inside the container. But as we already have another container which is up and running, let's take an example of these containers that we have. Let me take the container that we have over here. The container name is going to be this. So, oh sorry. So I will just copy this name. So instead of this, if I say my container name, IT, my container name, and hit enter, see, so it is pulling. Oh, I think it by default used Ubuntu itself. Uh, so right now, anyways, so it has created a new image for us where the image was not present. It pulled it locally, and as the new image got created, now I am inside that new container that has been created, and we can perform ls hyphen lrt. See, whatever commands you see, these are the containers. We are inside the container. So this is how you can interact with your container. Okay. Now, coming back, last and not the least. So nowadays you have been seeing many people are coming up with the AI solutions. So in the AI solutions, what they do actually is, as part of the AI solutions, they create an AI which would require a API key, that is the AI API key. Suppose I will provide you a solution that you can use with an API key of ChatGPT, of Claude, or any of them. So in that case, what you can do is, while running the container itself, you can provide that API key as an environment variable. When you provide that, that API key is going to be used when you're going to use that application in the backend. That is how you can use the environment variable to take the input, and you can use that as part of your code, which is there for the application that you have inside your container. So that is how you can use this command, and it makes it more powerful when you're going to combine all of this together. So almost we have combined all of this together, and you see that how the Nginx server came up and how it was working. So this is how you can do it. Now, for I'm going to go ahead and stop all of them and delete them. So later on, when it is required, I would be going ahead and creating them one by one. So there is not much of a clutter that we have. And you are aligned with me that whatever we are doing. So next we are going to talk about Docker PS command. So after creating containers, you need to see what's running and what's not running. There comes the Docker PS. It is available in the Docker desktop too, but when you're going to work in an enterprise, you're not going to use Docker desktop. Instead of that, you have to use the command line to see which Docker containers are up and running. And many a times it is handy to use the Docker command itself, because in your application or scripting, these kinds of command comes into picture when you want to extract some input from the containers that is available or up and running. So when you use Docker PS, the output shows the container ID, which image it's from, the container it's running, the current status, port mapping, and the container name. So right now I have cleared all of our containers that we have. So what I will do, I will use one of our command, this command, and I will run it. This is going to go ahead and create a new container. As you can see over here, this is our new container. So what I'm going to do is would say Docker PS, and you will see this container details over here, container ID, the image that we are using as part of that container, the command that we have as part of that container image, that is the entry point, how much time before it was created, what is the current status, it is up and running. Here is the port mapping that is available, 8280 TCP. So, and this is the name of the container. That is how you can use your Docker PS commands. Now, by default, Docker PS only shows the running containers. But if you want to see the containers which are not running, so in our case, we have two containers. This container is right now not running. See, it is in stopped state. So if you want to see those containers also which are not running, you can use the same command with -a and hit enter. And now it is going to show you the containers which are not running also with the status of exited. So this is how you can see those kinds of containers. So you will often use Docker PS-a to see the containers that you ran earlier. And there are helpful variations too that you can use. So for example, one of the variation over here that you can see is Docker PS-q. It is only going to show the container IDs. Many a times you don't need a lot of information, right? So right now it is showing a lot of information and you're just interested to get the container IDs which are running. So what you can do is I would go ahead and clear the screen and I would just say docker ps -q. So it is just going to give us the container ID which is running. And uh, these kinds of outputs are useful for scripting when you want to perform actions on multiple containers. Those are the running containers, and you can filter them also by their status, like showing only exited containers or showing only running containers and up and running containers. So there is one command over here that you can see. So you can run this command, and by using this, what you can do is you can go ahead and add filter and say you just need the ones which are in the exited state. So let's try. So we will use the same command over here. Okay. And this time, instead of using q, I'm going to use hyphen filter, and we are going to say status is equal to exited. So when I say that and go ahead and run, so you can see this time it has brought me the other container that we have right now, not just ran. It was from our first video that we created as part of this series. So this is how you can filter out the container output also by using the filter parameter. Now, so you should see your container listed with all the details, but if you don't want, you can use -q. And if you want to filter out based on the status of the container, you can use the specific filter parameter. Now, once you have the container running, you often need to execute command inside it. That's where docker exec comes in picture. The syntax is straightforward. You just say docker exec followed by the container name or the container ID over here. Once you do that, what it does, it is going to take you inside the container. Okay, so for us, we can say docker exec my nginx ls and the path of the HTML. This is where the application of relies, where you can see the index.html file. So I will go ahead. So now if I go ahead and run the exact command by giving the container name and the path in which I want to see which all files are present. So this is the HTML folder in which the index.html file would be present, which helps us. So when you go to Docker desktop, so over here, when you see the port mapping and when I click on this, so this is the actual page that it brings us to, right? Welcome to Nginx. So this is the HTML page that I'm looking for. So what I am going to go ahead and do is I am going to go ahead and hit on enter over here. Once I hit on enter, it will show the files present inside this folder. That is how you can use docker exec command. So this helps you to see all the files and directory inside that specific folder that you're looking forward for. So the real power actually uh, so this is, yeah. So now we have just went ahead and see the file inside that, but the real power is going to come when we are going to club that with the interactive flag for the interactive mode. So Docker exec IT, when I'm going to do that, it is going to open an interactive bash shell inside your running container. And now you're going to literally go inside the container where you can navigate directories, edit files, check configurations, install packages, and debug issues. So it's like based on this, you can go ahead and sh inside that too. So exec command is to go ahead and see what is the content. But if you want to go inside the container and perform any changes at that time, you can go ahead and use this specific command. Now, as our Nginx server is already up and running, so if you want to go ahead and cat the output of the Nginx config file, which is part of our container, you can do that too by using the command and that. So I will just close this by using the exact command. So let me show you that command too. So for that, what we are going to do is we are going to use docker exec and our nginx container. So I will just use the command docker exec my nginx, the container that we have, and we are going to cat the output of that specific file. So I will just go ahead and hit enter. So over here, while you're using it on Windows, you might get an error if you are not going to give double dash. Let me show you. If I hit enter, see, it is saying that no such file or directory found. you can resolve this error. Just go over here and instead of in the start of your path, just get double slash and now hit enter. And here is the output of the specific file that you can go ahead and get from the container which is up and running. Now, the key point over here for using exec is you have to make sure your container is up and running. If your container is in a stout mode, exec command is not going to work for you. Now, next comes the Docker logs. So Docker log is your window into what's happening inside your container. Based on this Docker log window, you can actually peep inside to see what's happening inside the apartment of the that you can say as a container. So every application produces output, error messages, access log, debug information. So in a container, this output goes to std out and std error, and Docker logs lets you see it. So simply you run Docker logs followed by the container name to see all of its output, which has been pushed to std out and std error. And this is absolutely essential for debugging when you're going to work with Docker. Your application, suppose if your application is crashed, what you're going to do? First thing, you are going to check the logs. If you are getting an error in your application, you are going to check the logs. So you are going to use this on daily basis. So right now, let's run the first command. I will just clear this and say Docker logs my my nginx, and you can see the log over here. So this is the log right now which is available. Now what I'm going to do is, so you can also use a lot of options that are very useful for checking the logs. So the first option that you can see over here is -f flag. It is incredibly useful and it follows the logs in real time, just like you use tailf in Linux. As new entries, log entries are being generated, you can see that in real time. So if you want to see the logs in real time getting generated while you're performing some testing or running some code, at that time you can go ahead and use this flag. So I will just clear this, and if I say -f over here and hit enter, so see this is, and right now it has locked my terminal, and if there is any new activity which is going to be performed on the specific container logs, it is going to show me immediately. So that is how you can go ahead and use the -f command to follow the logs in real time. Then you can also use -tail to see only the last n number of lines, which is useful when your containers have been running for a very long time or have a very massive log. For example, if you have thousands of lines in your log, and if you're going to open it in the terminal, it is going to be very difficult for you to read the entire log file. So instead of that, when you're working in enterprise, what you actually do is you tail the last few lines where you actually know that at this specific time the error has happened. So if it is in last 10 minutes, so sorry, if it is in last 1 or 2 minutes, you can just check the last 50 lines of code to understand, lines of logs to understand if anything has gone wrong, and you can troubleshoot it. So for doing that, what you will have to do is, I will just clear the screen. You will go ahead and say Docker logs tail, and I want to see only last 10 lines of my logs, and this is 1 2 3 4 till 10. So this is the last 10 line of my logs. So see, if I remove this and just use logs, see this is such a long logs. See, it starts from here, but now when I use the last 10 lines, see it is short. So this is how you can uh, just check the last 10 lines of the logs file that you have. Then we can use the since flag, which shows the logs from a specific time period. Suppose if you want to check for last 10 minutes, last 1 hour, last 30 minutes, so at that time you can go ahead and use it. So if you want, I will clear this, and now instead of tail we are going to say since and 10 minutes. So it has actually shown all the logs because we are uh, like our container has not been running longer than 10 minutes. That is the reason. But this is how you can use the since option, which helps you see. Now, if you want, you can also combine this multiple options and you can get appropriate output based on your requirements. Now, let's see the next command, which is Docker inspect. Now, when you need detailed information about a container, Docker inspect is your tool. While Docker PS gives you a quick overview, inspect is going to give you everything about that container. So when you run Docker inspect and my Nginx, it is going to go ahead and give you the JSON output with every minute detail about that container. So we are talking about network setting, including the container IP addresses and the port mappings, volume mounts, showing where the data is stored, all environment variables that has been created, resource limits, if you have set any, the current state of the container. So this information is invaluable when you're going to troubleshoot network issues, verify configurations, or understand how the container has been configured. Suppose if you have configured the container and I am the new joinee in your team and you have left the office, left the company, I am replacing you. At that time, you are not available over there to help me understand what is the configuration of this container. I can run the inspect command to see what exactly has been configured as part of this container, which helps me to understand the minute details of that specific container. Now, the output is JSON, which is detailed but can be overwhelming. So Docker provides a formatting options also as part of this command. So for example, if you just want to see the IP address, you can use the format parameter over here, and you can provide the uh, go ahead and provide the name of the configuration that you're looking forward for. So let's first see how overwhelming the response, the output is. So I will clear the screen and I will say Docker inspect my Nginx. Okay, enter. And you can see how this is the overwhelming response that I was talking about. It is giving you each and every detail. See the ID of the container, when it was created, the path, okay, the state of the container, then the image. Then you can go ahead and see the network settings over here. See the network mode is bridge, port bindings. So for this container, I have not done the 8080 thing. That's why it is not showing. So if you want to see that, I will clear this. So the other container that I have over here, let me take the name from here. So for this, it will show you the port mapping also. And I will paste this. And if I scroll up, it is going to show you the 8080 port configuration that we have done. I see host IP address, host port, host IP address, and host port. See, this information was not there in the previous container. So each and every minute details is available over here. And when you want to filter it out, filter that out. So for example, suppose if I want the network IP address, I can copy that parameter that I'm looking forward for, filter it out, and it is going to help me provide the output of that specific uh, parameter that you want. So this is how you use the inspect command. Now, let's see how these commands work together in a typical workflow. So when you want to go ahead and spin up a container, as we already did, you can use the detached mode so that it is going to run in the background. Then you can do the port mapping so that it is available when your web application is up and running, and you can also provide a name to it. So let me go ahead and create a new container for you so you can see the entire flow end to end. So here is the command. I will go to the terminal. First and foremost, I will clear the screen for you. Then I am going to paste the command. So what we are going to do is, first we are saying docker run detached with port mapping 808080 and the name my app nginx. Now this is going to give me an error. The reason for that is that port is already being used by this specific container that I have created over here. So what I will do, I will stop this container gracefully. Once it is stopped, I will delete this forever. And now I'm going to go ahead and run this. So it is not going to give me any error. So after the port, I am also giving a name. So the name of our new container that we are going to create is my app. And if you see over here, there is no my app present container. I hit enter and the container is successfully created. And here is your container, my app. And when I'm going to click on this, again, it has taken me to the specific page where the Nginx web server is available. That means our container is up and running. Now let's see what's next. So now as our container is up and running, it should be available for us when you are going to run Docker PS. So now we want to see the details of the container that has been created. I will say Docker PS. Okay, so now we have verified that it is running on the Nginx image. It is the state is up and running, and the port mapping is also done along with my custom name. Then after that, we are going to view some logs which are been generated for our my app. So I will go ahead and say Docker logs my app, and this is the log for the container that we have created. This is how you can view the logs. Next, we are going to go ahead and perform an execute command inside our my app. So this is going to be a combination of exec as well as it. So I would say docker exec interactive, that is hyphen it, and my app and bash. And once I hit enter, we are inside our container. If I say ls hyphen lrt, you can see this is our uh, Nginx web server container, and these are all the files associated with that as part of that container. So right now I'm not inside my Windows machine, I'm inside my container. So if I say exit, so I have actually exited now from the container. Now let's see what's next. So next you can go ahead and perform docker inspect to see all the details about the container that has been created. I would say docker inspect my app, and this is the overwhelming response that is over here. The port mapping 8080, the network information, the host name, the domain name. So all the information is being verified over here. Now if you want to see the logs in real time, what you can do is you can go ahead and just use the same logs command, and inside that logs command I'm just going to add one parameter -f. This is going to show us the live logs. So now if I'm going to keep the terminal as it is, because it has logged now, so it is going to show me whatever new logs has been generated. But I will press Ctrl C, and I have exited that operation or the CLI which was running in the background. A Docker file is simply a text file that contains instruction for building a Docker image. Think of it as a recipe, step-by-step instruction that Docker follows to create your custom image. The file must be named as Dockerfile. Just remember this naming convention. If you make it as Dockerfile, then only it can read it properly. Okay, so where it starts with the capital D, and after that everything is the lowercase. Okay, what makes Docker files powerful is that they are declarative. You describe what you want and Docker figures out how to do it by itself. Each instruction in Docker file creates a layer in your image. Remember from our architecture video, that was the second video in this series, images, where I taught you images are built in layers like transparent sheets stacked on top of each other. This layering makes images efficient because layers can be cached and reused. I will explain that in detail about that in a bit. A simple Docker file must start from an Ubuntu base image, update the package, install Python, and specify a command to run. So this is a simple example. What we are doing over here is we are saying we want Ubuntu. This is the base image of Ubuntu and the version that we want. Then we say that after we have the base image, then we are going to go ahead and update the base image. So whatever dependencies are there which needs to be installed, it is going to be installed. Then we are going to install Python on that machine, and then at the end we are going to go ahead and say Python, it is going to start our Python. So this is how your basic Docker file looks like. The beauty of Docker file is it's reproducible. The same Docker file will always build the same image whether you are on the Windows, Mac or Linux machine. or whether it's today or next year. So anytime you run it, it is going to create the same image without any discrepancy. This eliminates the works on my machine problem completely. Anyone can take your Docker file and build an identical image on his machine too. Now let's explore the essential Docker file instruction. Guys, this is very important. Please pay attention over here. First is from. This is mandatory and must be first instruction in your Docker file. It specifies your base image, the foundation you are building on. You could start from a minimal Linux image like Alpine, or from an image that already has tools installed like official Node.js image or something. I showed you in the Docker file, there are a lot of images. So let me go ahead and show you once again. If you remember from our second video, I took you to the Docker Hub. So in Docker Hub, there are n number of images which are available, right? So if I say Alpine, see, there are a number of images which are available. Some Alpine might be having Node.js installed. See, some Alpine is having Kubernetes installed. Some is having Helm installed. So you need, yeah, you can take it based on the preferences that you want. So, for example, suppose we are taking an image which has Node.js installed. So starting from a Node 18 means you get Node.js pre-installed, saving your installation step. If you don't take it from a Node 18, you are going to first take an Ubuntu image, then you are going to install it like we did in our previous one, right? But now we are saving our build time. We are taking an image which is already having Node.js installed for us. Next is our working directory. This sets the working directory inside your container. Think of it as a CD into your directory. Once you set your working directory to /app, as you can see on the screen, all subsequent commands like run or copy happens in that directory. It also creates the directory if it does not exist in your container, which is very convenient. Next is then we have copy. This copies files and directories from your host, that is your local machine, into the image. For example, copy package.json/app copies your package.json file into the app directory, that is the working directory that we have set in the image. Copy app copies everything from your current directory or the current path that you have mentioned into the working directory, that is a /app. So this is how the copy command works. It copies the file from your host to your uh, container. So these three instructions from work directory and copy are the foundational and the most used instruction in your Docker files. So you start from a base, set your working directory, and copy your application code into the image. What is application code? Suppose if I am running a Streamlit application, I am going to copy the application code. So when my container is up and running, the application should start working. Now, let's look at execution and configuration instruction. First was the base things, building the base layer, then installing some dependencies and copying the file. Now comes the crucial part, that is run. It execute commands during the image build process. Again, I am saying image build process. Each run instruction creates a new layer. For example, run npm install would install all Node.js dependencies into the image, and run apt get update would update the packages. So every command over here that you run, every command is going to create a new layer. So run executes at the build time. What is the build time? The build time of your image creation. So when you're creating the image, not when the container is going to run. So you can use run for installation and setup task while you are building your image. Next is command. Now, this specifies the default command that runs when a container starts from your image. So there can be only one run command instruction in your Docker file. If your Docker builds a Node.js application, as we are taken in our example, so CMD might run node app.js. So this is the command node app.js. So to start your application. So once this command is going to run, so once you are going to create a container out of this image, once the container is up and running, it is going to run this command in the background. So this runs at the runtime again. The difference between run and command is very crucial. understand it properly, run builds your image, and command runs your application. Finally, expose, that is the last one. So expose documents which port your container will listen on. So over here I have mentioned expose 3000, which tells Docker and anyone reading a Docker file that this container expects to communicate on port 3000. Note that export does not actually publish the port, it's the documentation. So the person who's going to run the specific container, he should understand where he should communicate with the container while he's going to create this. And you still need to use the -p flag with docker run command to actually map the ports from the local to the container port. Now let's understand env and arg. Both deal with variables, but they are going to serve different purposes. First is environment. So environment sets the environment variable that will be available when your container runs. For example, over here, environment node underscore environment is equal to production sets the node environment to production, and your application can read this variable at the runtime. So web servers often use environment port is equal to 3000 to know which port to listen on. So these variables persist in the final image and are available to your running applications. They are perfect for configuration that your app needs at runtime. On the other hand, ARG is for build time variables. Build time is when you're building your image. The previous one was while you are running your container. The second is while you're building your image. These only exist during the Docker build process, not in the running container. You might use ARG for things like version numbers or build configuration. For example, ARG version is equal to 1.0. Okay, lets you reference that the version during the build that you have set, but it won't be available when the container runs. It is just for your uh, for maintaining the version of the images when you create the version. Let's understand that also. For example, if I take you in the previous example, okay, this small example. So this is my first version. Now instead of using python 3, I am using python 2. I have made a change, so whenever I make a new change to my image, I can version it while I am building it. So that actually documents that what changes I have made, so the people who is using it, he would understand that there has been a change in the image. Or many a times you forgot to put some steps inside the image build, you add it later on and you change the version. So you can also pass ARG when building. That means when you're going to use the command, at that time you can pass the environment variables as well as the ARG. I hope you remember when I ran the docker run command, I passed the API key. That over there I was using the environment variable. So when I ran this, it was supposed to be available to the running container. That's why I ran with the run command. But this we are going to use with the build command that we will see in the next video, which we use to build the images based on the Dockerfile. So this flexibility makes ARG useful for creating different builds from the same Dockerfile. Now let's talk about the best practices starting with layer optimization, and this is uh, going to be your interview question for sure. Remember, each instruction in Dockerfile, each instruction that you run, that is run apt get update, install apt install vehicle, ygit, every command that you run, it is going to go ahead and it is going to create a new layer. So look at the bad example over here. Okay, three separate run commands means three layers are going to get created. Each layer is stored and they can't be merged later. This bloats your image size. Automatically image size will become big. So now we come to the good example, which combines all the commands into single run instruction using and to chain them, and the backslash to split the commands across multiple lines for your readability. This just creates one layer. Notice we have also added remove RF and the path provided over here along with the wildcard. What it does is this is going to clean up the APT. The APT, whenever you use the APT command, it is going to cache and within the same layer. So what we are doing is we are going ahead and cleaning up that cache within the same layer so that the temporary data which the APT use doesn't get stored in the image. This also reduces the size of your image. So this is the kind of questions that you would be asked while your interview as a DevOps engineer or while you're working in an enterprise. This is the kind of optimization you have to do. And here is why it matters. Docker layers are immutable. If you create a file in one layer and delete it in the next layer, the file still exists in that first layer, taking up the space. By doing everything in one run command, you can create and clean up temporary files within the same layer. This technique can reduce image sizes from gigabytes to megabytes in some cases. For production images, the smaller it is, the better. Because if it is smaller, we have faster downloads, faster deployments, and less storage cost. Now, the order of instruction in your Docker file dramatically affects build speed. And this is because of the Docker layer caching. Now, here is how it works. This is also very important. So Docker caches each layer. As I said in the previous example, when I say Docker apt update, take at the bad example. When I do this, it is going to cache one layer cache. Then I will go to this second command. This is again cache, second layer cache. Then third command, third layer cache. Three layers cache is going to make your file size too big. Now, as I said, Docker caches each layer, and when you rebuild, it uses the cached layer until it hits an instruction that have changed. So suppose if I have used a command, for example, uh, apt install update. If there are the packages which are already installed and there is no changes in the updates came from that official image, it is not going to make any change. But if it is there, then it is going to make a new change and the new cache will again be created at that specific layer. Now, once a layer changes, all subsequent layers must be rebuilt. If the first layer changes, the other also rebuilds. So look at the bad example over here. We copy all our code first, then we run npm install. So every time you change any line of the code, even a comment inside that code, Docker sees that copy instruction change and invalidates the cache which was already there and reinstalls all the npm dependency again. That slows your image download or image build process. So for example, in our previous video, I went ahead and I ran hello world. Docker run hello world. So the hello world was not there available on my local machine or on local cache. So it went to Docker Hub, it installed it, then it went ahead and ran the container on it. So every time it is going to revalidate, it is going to do the same thing. It is going to get back the data from web or Docker Hub, and that is a waste of time in your enterprise application. Now, if you see at the good example, the over here, what we have done is it copies the package.json first, that runs npm, then we run npm install, then copy the rest of the code. So now the npm install over here only reruns if the package, that is package.json, has changed. That is, code changes don't trigger dependency reinstallation because those layers are still cached. Understood? This saves minutes on each build, and each minute matters when you're going to do that in your production deployment. The principle is simple. Put instruction that change frequently at the bottom of your Docker file and stable instruction at the top. So as we know, our this is our code base, right? That is the application. We know whenever we are going to make any changes, we are going to uh, make it in the app. So why to keep it up? Every time you do that, then again it does the same process. So instead of that, you can keep it down so it does not have to do the revalidation for the above layers, because if the first layer, if it is on the first and the bad order, if it changes, it is going to rebuild all the other layers. So dependencies don't change often, so install them early. So this kinds of dependencies don't change often, so install them early. And your application code changes constantly, so keep it at the last. And this optimization is crucial for development workflow, which results in faster builds, means faster iteration and happier developers and customers. Now let's see a complete production ready Docker file that incorporates all our best practices that I just discussed. So we start with from. So over here, we take node 18 Alpine. So Alpine is the minimum Linux distribution that creates much smaller images than the standard based images. So when you, if instead of this, if I would have used Ubuntu, then install Node.js, first of all, it would have wasted time, as well as the Ubuntu image is bigger. But this is going to Alpine images always smaller. It only have required dependencies installed. It is not going to have everything else installed by default, like the base images of Ubuntu. Then we set the working directory to app. So what is the benefit of this? So after this, whatever we application code we are going to copy, it is automatically going to get copied into our slash app on our uh, container that we are going to create, okay, or the image that we are going to build. Now, copy package files. As I said, if we use package.json, as this does not gets modified often, like code, we are going to keep it first. Then we install the dependencies. Okay, so over here you can see, then we run npm ci, which is better than running npm install. So for production, because it's faster, more reliable, it installs exactly what's in the package dot json dot log file. So we only use hyphen hyphen only is equal to production to skip dev dependency, making the image smaller. And only after dependencies are installed do we copy the rest of our application code. This ordering means code changes don't trigger the reinstallation of all the layers. And then we set the node environment to production. So our Node.js application, which is going to run, it is going to run in the production mode. And last, we are going to go ahead and expose the port 3000. It is not going to expose the port, right? It is just going to document. So the developer who is going to use the container, he knows that which port he should communicate with, and he's going to use that in the run command while he's building the container. And finally, the command starts our server. So this Docker file that you see over here is optimized for build speed through caching, minimized for size through Alpine, and production dependencies are allocated to it for, and it follows all the Docker best practices. If you write this kind of file, just copy this code and give it to any of the chat GPT, Claude, or any GPTs, they are going to say that this is one of the best Docker file that is industry level. So this kind of Docker files you would use in real project. It's clean, efficient, and maintainable. Anyone can read it and understand exactly what the image contains and how it's built. So over here, you don't have to only focus on the code that I am writing over here, that is Docker file. Make sure you provide proper comment. So if your colleague who is going to work with you on the same Docker file, he can understand what exactly each command is doing. So commenting is kind of documentation that should also be done in your Docker file as part of best practice. So let's start with building images. Once you have a Docker file, you use docker build command to create an image. And this is how the build command looks like. Now, before going to that, let me just remind you, in our last video, we created the Docker file, and we are going to use the same Docker file to perform a build over here. Now, the syntax is straightforward. Docker build hyphen t my app colon 1.0 space full stop. Let me break this down. The T flag is for tagging. It gives your image a name and a version. Here we are naming it my app with the version 1.0. So this is the name and this is going to be the version. Now the end is crucial. It specifies the build context, which is the directory containing your Docker file and application files. Because when you say full stop over here, that means by default it is if it has to, this is the work directory. When it wants to copy the package.json or something else, it is going to pull that from your current directory. Now, usually you run this from your project root. So the dot means the current directory. When you execute this command, Docker reads your Docker file and follow each instruction sequentially one by one. Each instruction creates a new layer and this layer stacks to form your final image. Docker shows you the progress as it builds. you will see each step executing, where you will see first it will pull the image. Once it is available, then it will go ahead and start building. And whatever steps we have mentioned over here, you can see that it is performing all these steps one by one as part of the image build. If everything succeeds, you get a fully built image tagged as my app 1.0, which is ready for your use to create a container. The build process is deterministic, that is, the same Docker file and the files always produce the same image. So suppose if I'm going to give this Docker file to you, it is not going to create a separate image for you, separate image for me. It is going to be the same for both of us. This is what Docker builds reliable and reproducible feature is. Now let's understand this. So as we have already understood Docker build, how we have to use. So I will jump to the terminal and I'm going to use the command docker build -t. Our app name we are going to give, image name we are going to give my app, and colon the version 1.0 space dot. So now when I go ahead and hit enter, the build will start, and let's see how the build has gone through. So you can see all the steps. We will actually verify it with our file that we have, that Docker file. So first and foremost, it is going to go ahead and get the node 18 alpine image. Once it has, it will load that in the metadata. Suppose if we are going to run it multiple times, the first time only it is going to download. From the second time onwards, if it is there already available in the cache, it will use it from there. Then second, it is going to go ahead and create a work directory, that is /app. Then third, it is copy package.json. So it is going ahead and copying package.json file. So I will show over here. So this is our package.json. You can see just a demo app. So it has gone ahead and copied that as part. Then it goes ahead and perform npm install. Once it performs the npm install, then we do copy dot dot. As part of this copy dot dot, what it is going to do is it is going to copy all the content, that is the context, from our current directory to the image, and then it goes ahead and creates the image for us. How the image looks, if I take you to Docker Hub, you can see over here, see our image has been created successfully, and these are all the details of our image. Now let's understand the build context, because understanding the build context is crucial for efficient builds. When you run Docker build, Docker doesn't just read the Docker file, it sends the entire build context to the Docker daemon. The build context is all files and directories in the location you have specified. Typically your current directory that we have given. So our current directory was /app. And here's the problem. If your project has a huge node underscore modules folder, which is there, which would be there for sure if you have it installed on your local machine, with thousands of file, or a Git directory with your entire repository history or large log files for the Git, Docker will package them and send all of that to the daemon. This makes build incredibly slow. Even though you don't need those files in your image, by default it is going to get that as part of build context, and it is going to make the image bloated. So the solution is you have to have a docker ignore file, which works exactly like I explained, dot git ignore file. So if you create a docker ignore file in your project root folder and list the patterns for the files and folders Docker should ignore during the build process. So common entries are node modules, git, log files, environment files, and test files. So I will show you, I have a sample of that too. So if you go over here, I have, see, I am ignoring the node modules, that I'm ignoring the logs, then I'm ignoring the environment file, then Docker, Docker and CI, Git, editor files if there is any, Git files, operating system files. So these are all the files that I'm ignoring. Now, as a fresher to get started, you might get confused that which all things I should use. So in that case, what you can do is you can go ahead and search for Docker. So just type Docker ignore template, and once you hit enter, it is going to show you one website, dockerignore.com. If you go to that website, you will see a list of uh, different Docker ignore files which are available that you can use as your starting point if you don't have much knowledge that which all files you should ignore as part of the Docker build process. It has a template for all of the languages. So right now, as we are doing Node, so Node is not over here. So I will go to the next page, and over here you can see Node will be available. See, Node is available. Click on view, or you can click on copy to directly copy the content. But right now, I'll click on view. Over here, it has told you that for Node.js project, which all files or folders you need to ignore. So these are, you can get started with this without having much of the knowledge as a fresher. Now, when Docker builds, as I said, it excludes this, making the context much smaller and the build becomes much faster. And this is especially important in CI/CD pipelines that you're going to create, where you might be building frequently based on the changes which are coming in from multiple teams. So a Docker ignore file can reduce build times from minutes to seconds by excluding unnecessary files, which is not required as part of your image build process. Now let's understand image tags properly. A tag is how you identify and version your images. The full format is what you do is you provide the registry name, the Docker Hub registry, or the account. Suppose if it is your personal account, you can put your username over here, okay, and you can provide the version. So if you just use my app, Docker assumes if you are just going to go ahead and use my app and you're not going to give 1.0, so by default it will tag that image with latest. So whenever a new one is going to come above that, it is going to be the latest, showing you that this is the latest push that you have performed for this specific image. So you can also use semantic versioning like 1.0.5, in which one would be the new feature, zero would be one would be a new story, zero would be a new feature, and five would be a bug fix. So this is how you can use semantic versioning. And when you're preparing to push to Docker Hub, you include your username, as I said already. So it is going to be your username slash my app colon the version that you are providing. Now, best practices says that always use explicit version tags in production. The latest tag is actually misleading because if you are not going to provide anything, it is going to go ahead and create the image with latest tag. So for example, if I go back over here, let's try to build another image. Oh, sorry, with the same command. And this time what I'm going to do is I'm not going to provide 1.0. Okay. And we would say new my app. And let me show you how it will be tagged automatically with latest. So if you go to Docker Hub, we don't have that image over here. Okay. So I will just go ahead and hit enter, and it is building the image. Once the image is built, if I take a Docker Hub, see by default, it has tagged it with latest. So this is how the automatic tagging happened. But when you're working in production, you should always use the tag as a version in a semantic format. So that is the best practice you should always follow. Now, if you deploy my app colon latest, you can't be sure which version you are running currently on your production. So instead, you can use semantic 1.0.0, then 1.0.1, 1.0.2, 1.0.3, and when the story changes, you will make it 2. Then again, you will go ahead with the series. And this makes it crystal clear which version is deployed and which version you need to roll back in case of any issues with your deployment. And you can also tag for environments, like you can add a tag as development. So if it is a development image, you can say as dev. If it is a production image, you can say it as prod. And tags are free. You only apply multiple tags to same images. So good tagging is essential for image lifecycle management and deployment tracking. So once you start building images, you need to manage them on your local system. So once the image is built, how you can list which all images are now available on your machine. To do that, you can jump to the terminal and you can say Docker images. It will list all the available images in your current local system. Now, uh, if you want to see images, there are two commands, Docker images as well as Docker image ls. So the output shows the repository name, tag, unique ID, unique image ID, and when it was created, as well as its size. So you can quickly accumulate many images with different versions, base image pulled from building, and so on. Now, the next challenge comes in. Suppose if you have a lot of images and you want to remove some image. For example, I want to remove the Hello World latest image. So what I can do in that case? So do that, I can go ahead and use a Docker remove command. So when I say Docker RMI, Docker RMI, so we have two commands. First is Docker RMI. Then you can give the image name, or you can use Docker image remove the image name. So these are the two ways by using which you can go ahead and remove the unwanted images that you don't want on your machine. So what I'm going to do is I am going to say Docker image, and I'm going to copy this over here, copy, and I will paste it. So before doing that, let me show you the Docker Hub, where you will see how many images I have on my local machine. You can see I have 3 images. Now I'm going to remove the first image because it is of no use for me right now and just occupying my space. So I would say Docker RMI Hello World latest. So it has removed the image for me. And now if I go ahead and say Docker images, you can see that the third image has been removed successfully. Now, one thing to remember, that you cannot remove images if a container is using it, and you would need to start and remove the container first. For example, right now, if you see over here, if I go in containers, see container is not using any of the image of mine. So what I will do for the second one, I will just click on run, and I would say it is saying, do you want to run a container? I would say yes, run a container. So my container has started running. So if I go in containers now, you can see one container is up and running, and the image associated is this. Now let's go ahead and see if I use the same command, remove, and now the Docker app image, I will just try to copy this, copy, and I will paste it over here. And now if I try to remove this image, it is going to give you an error. See, error response from daemon, conflict unable to delete. If you want to delete it forcefully, you can, but by default, it is informing you that as the container is running or associated with this image, that is the reason you cannot delete it. So if you want to delete that image too, you will have to remove the container, then you can go ahead and remove the image. Now, let's talk about some dangling images. So over time, you will be having dangling images. So these are the layers that are no longer tagged or referenced. Suppose if right now you are on version 10.0, but there are some dangling images which are not required now. So there is no use of it, and it is just going to occupy your space. And they take a space for no reason, which is not at all fruitful for the business. And so in this case, what you can do, you can use Docker image prune command to remove the dangling images. So which will help you freeing up your space. And if you want to be more aggressive, then in that case, you can use Docker prune -a. This is going to remove all the images that aren't currently used by any container. So it is going to check also if it is used. Suppose I have list of 5 images, it is only going to delete those which are not having any container associated with them. If there is any, it will leave that. Otherwise, it is going to go ahead and prune it. And this is useful for cleanup, but be careful as it removes everything unused. So you might need to re-download or rebuild the images later. A regular pruning keeps your document environment clean and prevents your disk from filling up with old images. Now, before we push our images, let's understand Docker Hub. So Docker Hub is a default public registry for Docker images, and it's essentially like GitHub, but for Docker images instead of the code. When you run Docker pull nginx that we did in our third video, what Docker do is, so Docker is going to download it from the Docker Hub, and then it is going to go ahead and run. So if in our case also, what we had done, if I take you to our code, so this is our Docker file. So when we mention from node colon 8 hyphen alpine, where it is going to bring the image from. So as soon as we are going to build this image, first thing it will go to Docker Hub, get that image for us, and then it will start building it. So Docker Hub plays a very crucial role with holding the images that we required in our image building. Now, Docker Hub hosts thousands of official images maintained by companies like Ubuntu, Node.js, Python, and Nginx, and it also hosts millions of community images. Let's see that. So if I go to the official Docker Hub, over here you can see it has Docker official images, verified images, community images, Docker hardened images, whatever images you want, you can, and you can also categorize that based on the categories which are available over here. So right now over here, see the first category is machine learning and AI. Then the other category, the most pulled one is Nginx, BusyBox, Alpine, the one that we used. So you can find n number of ready-made images available. So creating an account on Docker is free and very simple. I have already explained that as part of my second or third video. You just have to visit Docker Hub and you have to sign up. And the free tier gives you unlimited public repositories but limited private repositories. So public repository means if I go to my, this is my Docker Hub account. So if I go ahead and check, see in repositories, this is my hub, right? So as part of my hub, you can see I have one public repository. So I can have n numbers of public repositories over here. But if I want some private repository for myself, then you would have to move towards the paid plans, which offer more private repos and additional features. Okay, so let's now understand why we use Docker Hub. First and the foremost thing is collaboration. Your team can pull the same images, ensuring everyone uses the identical environments. Second is if you are building an open source project, you can publish images for users to easily run your software without building it themselves from scratch. And third is deployment. Many hosting platforms can pull images directly from Docker Hub for deployment. So nowadays it's a standard way to share Docker images. Once you have an account, you are ready to push your custom images and share them with the world so they can start using it. So now get ready to push an image to Docker Hub step by step with me. So first you need to authenticate. So to do that, what you will do is first and foremost, you will go ahead and log into Docker Hub. Now to log into Docker Hub, you have to use the command docker login. Once you use this command, it is going to ask for your username. Then once you provide username, then it is going to ask for your password. And when you hit enter, it will authenticate you. If it is correct, then it is going to go ahead and allow you login. And Docker stores this credentials securely, so you only need to log in once per machine. Now there is one more thing into it. So if you're using it on Windows and you have already logged in on your Docker desktop, you don't have to log in again because your login is already available at Docker desktop over here. So let's go ahead and try this command. So I will go ahead and say docker login and hit enter, and it is authenticating with existing credentials. See, it has my username and password. The reason for that is it is available over here. See, on our Docker Hub. That is the reason. But if you want to log into another account, so for that, what you will have to do right now is you have to say Docker run logout. It will log out of your current account, and then you can log into another account if you want to as part of this process. Now, next, you need to tag your image properly for Docker Hub. How you will do that? So image on Docker Hub must include your username in the tag. So if you built an image, which we have already built, that is my app colon 1.0, we need to retag it as username my app colon 1.0, where username is your Docker Hub username. So we have to retag it with this. So right now we have just tagged it like this. We have to retag it with it like this. So we are going to do here is we are going to use docker tag command, which is going to create a new tag pointing to the same image. It doesn't duplicate the image. It just add another name reference. And now we do after we do this, then we are going to be ready to push the image to Docker Hub. So let's do the second step. So as part of this step, what I'm going to do is I will go ahead and say Docker tag space my app colon 1.0 to my name Dheeraj Chaudhary. If you don't remember the username, you can just check it from the Docker Hub itself, or you can also see it gave my username over here. So I have used the same username over here, and then I will say slash my app colon 1.0. Once you do this, over here we are retagging it with 1.0, retagging it with a new reference, but it is not going to rebuild the image or change image in any ways. I will hit enter, and this process is done. So what's our next step that we have to do? So now after doing this, we are ready to push. So now we are going to go ahead and run the command docker push the new tagging that we have given, that is a username my app colon 1.0, and the Docker will upload your image to the Docker Hub, and you will see the progress bars and everything, like each layers which is getting uploaded as part of this process. So let's go ahead and try that. Now I would say Docker push Docker push and my name, that is the repository name, Docker Hub repository where we are pushing it, and my app colon 1.0. And now I'm going to go ahead and hit enter. So see, it says that the push refers to the repository. It has gone to the correct repository in the docker.io, and it is pushing our image. Now see, it is showing that how much MB is uploading and everything. So this layering is going to show you end to end how your file is going to go ahead and upload it. So right now it has uploaded the file size with 856. So let's go ahead and see what is our image that we retagged. So this is 856. So it is 180. So it has 856. That means it is not showing with KB or something, but that is the difference. So right now it is over here in MB. Maybe that might be in KB or something. So this is how you go ahead and push your Docker image to the Docker Hub. So this process is super fast. And now if I take you to Docker Hub on our official website, let me reload this. Okay. And if I say, okay, so right now this is my hub. I will click on my hub, and you can see our image has been successfully pushed 1 minute before. And this makes pushes very fast. Once complete, we can visit our specific account and we can view the image online. And now anyone in the world can pull your image with Docker pull username. So if somebody wants to pull this image, so if you click on that image, see the public view is available over here. So if you want to pull the same image of mine, you can use this command based on which you can pull the image. And this is how you distribute the Docker images for your team, for your open source project, or for commercial products. Now let's put everything together and see complete image lifecycle from start to finish. Right now we were looking at it in a broken structure, but let's do it one by one. So I will just go ahead and clear this. So if I say ls -lrt, you can see these are the files available, and this is our Docker file. So if you have not created your Docker file, what you can do is you can use vim command to create a Docker file. If the file is already existing, I can just view my file by saying cat Dockerfile, and this is the content of our file. If you want to make any changes, use vim, go inside, make any changes, and come back. Once you're out, then what is the next step that we're going to perform? Then we are going to build the image. So right now, the previous image that we built, it was with my app. Then the second one was with new app. So what I will do, I will again build the image with some new name. So I would say Docker build -t. We are going to use this because we are tagging the image name, right? So the tags that we're going to add is, I would say Docker app, and after that I will say colon 1.0. That is our version. So, and I will go ahead and say full stop. So this is going to use my current directory Docker file along with all the build context, and it is going to build the file. But this time, as I said, the build is going to be super fast because our image that we need to pull from the Docker Hub is already in cache. Let's see if you see that message. So see, it is super fast. And over here it is saying load metadata for docker.io. So that means it was already available in our cache, and it didn't went to Docker Hub to pull it. It is already available, as well as it is installed on our local machine. So this is how we are going to go ahead and build. So now we built our image. Now we can go ahead and run this to understand if the container is coming up or not based on this image. So I will clear this. First step, creating Dockerfile. Second step, creating image. Third step, to run the container out of that image. So this is the third step, Docker run -p, and we would do mapping 8080 colon. So in our Docker file, we have mentioned 3000. So we can say 3000, and I would say my app colon 1.0, and I will hit on enter. See, it is saying Docker node app running successfully. Why you got this message? The reason for that is, if you go in our file in index.json, see, I have added console log Docker node app running successfully. This tells you that on the console itself that the Docker node app has been appropriately configured, container is appropriately configured and running successfully. Now I will do Docker ps, and you will see the container actually went ahead and closed. But over here you can see, if I go to containers, so this was the container C which got created 38 seconds ago. So right now it is in stop state. See, that's why. So that container is just going to create. I am not keeping that container to run for long. It is just for demo purposes. Now, what is our next step? So after we built our image, we checked our container is getting created or not. Our container got created successfully. Then the next step is going to be, we are going to tag our image that we have based on the Docker Hub on which we have to upload it. So for that, what I'm going to do is, oh, sorry, one mistake I did. See, over here I have used my app. It is not my app. It is Docker app that we created, and I would say Docker. See, for that also, the Docker node app is running successfully. Now let's move to the next step. Now we are going to tag our image so that we can push it on the Docker hub. So for doing that, what I will do, I will go ahead and say Docker tag Docker app colon 1.0, and my username of my GitHub repo, and slash again Docker app colon 1.0, and I will hit on enter, and the tagging was successful. If the tagging was successful, it will show it over here only. If I go to images, let's see this. See, Docker Dheeraj Chaudhary Docker app. So a new tag has been created for the same image. Now it's time for us to perform the next step. So what is our next step? We are going to go ahead and push this to the registry. So let me show you the registry first, so you are sure that it is not available. So right now, if I go to repositories, you can see we only have this repository available. Now, once I push that, we would be having one more repository available, inside which you would be having the image. So let's do that. So for doing that, I will again jump to the console, and I would say Docker push the username of mine, and slash, I would say Docker app colon 1.0. Now hit on enter, and you can see it is pushing it. Once it is pushed successfully, it gives us the message. Let's see over here. If I refresh it now, and you can see our Docker app has been successfully pushed. Now, after we do that, what exactly we can check? So for Sorry. So now we can go ahead and pull the image to see uh, how we can pull. So for pulling the image, I will go over here. So this is where our image is available. Okay. So this is the public view. So if we want to pull this image, I can click on this image. Okay. And I can check the details of this specific image that we have over here. So these are all the details. And when I click on Docker app, so over here, if you want to pull it, you will get the command to pull it. So if I say public view, so this is the public view. And as part of the public view, you can now see the pull command. As I was in the admin view, that's why I was not able to. But when you are going to visit, this is how you will see it, and you will have the command available over here itself. So if I copy this command, I will just go ahead and say paste and enter, and this is going to go ahead and pull the image. Now you can see the image is up to date. So this has pulled the image and made it available on my local machine. So that is how you can pull the image, and the image that you have pulled, if is that image actually working up and running. You can go ahead and check that by running the container once again. So let's understand the fundamental problem with container data. Containers are designed to be ephemeral, that is temporary or disposable. I hope you remember from our architecture video that images are read-only layers, and contains and containers are a layer which is a writable layer on top of that images. So all changes, file created, file created, data written, goes into the writable layer. And here's the problem: when you delete a container, that writable layer is destroyed, and all data is permanently lost. Imagine you're running a MySQL database in a container. User adds data, the database grows, everything seems fine. Then you need to update the database version. So you delete the old container and start a new one. And boom, all your data is gone. It's erased, it's deleted. Then you need to update the database version. Sorry, the same applies to any application that generates data, like log files, user uploads, and configuration files. So if it's stored inside the container, it's temporary. This behavior makes sense for stateless application, but many applications are stateful. They need to persist data. Suppose if we have an ad hoc task that needs to be performed every day without thinking about anything like data storage or something, for that ad hoc task, it is okay. But for stateful application, which depends on the data which is being downloaded or data which is being created as part of that application, then it is important to preserve that data. And we need a way to store data outside the container file system, so that even when containers are deleted, created, or updated, the data remains safe. That's exactly where Docker Volume solves the problem. So Docker provides three main ways to persist data, and it's important to understand when to use each one of them. First comes the volumes, and they are managed entirely by Docker. Docker creates them, stores them in a special location on your host machine, and manages their lifecycle too. Volumes are independent of containers, so if you delete all containers, volume remain until you explicitly delete them. This is the recommended approach for production workloads if you are using Docker. Second comes the bind mounts. So these directly mount directly from your host machine into a container, one-to-one mapping. For example, mounting your project folder, so changes in your code editor immediately reflect in the container. Bind mounts are great for development because you get real-time synchronization, but they are less portable because they depend on specific host paths. Third comes TMPFS mounts. These are stored in the host memory, not on the disk. When the container stops, the data disappears because the memory is cleared. So they are useful for sensitive data you don't want written to a disk, or for temporary caching. So today we are focusing on volumes because they are the most common, most portable, and best practice for persistent data in production environments. So volume solves the container data problem elegantly. Let's see how. So let's understand how we create and use volumes. First, to create a volume, you can explicitly go ahead and use the command docker volume create and the volume name. So this creates an empty volume named my data, which is going to be managed by Docker. You can also let a Docker create volumes automatically, which we will see in a moment. Suppose if you are not going to go ahead and give the name, it will give the name by itself. Now, to use the volume with the container, we need to add a v flag, -v flag, followed by the volume name and the container path. So let's understand this by an example. So over here you can see I have used a docker run command by using which you can run a container. Now inside this command, what we are doing is, so you can see over here, uh, -v my data colon /var /lib /mysql. This mounts the my data, that is a Docker volume that we have just created, to the path inside the container. And why we are using var lib mysql? Because that's where mysql store its database files. So you should be aware of that too, for based on the application that you're going to use. Now here's the magic: when SQL writes data to lib MySQL, it's actually writing to the volume, not to the containers file system. So if we would have not added this volume to the container and just spinned up the container, as soon as I delete the container, stop the container, the data would be lost, because it was just for that time period when the container was running. But now, as we have added the volume, so now it is going to sync with the Docker volume that we have created for ourselves. Now the volume lives outside the Docker outside the container in Docker's managed storage area, and you can stop the Docker container, delete the Docker container, or even update to a new MySQL version in a new container. And as long as you mount the same volume, all data is preserved. The container sees this path, that is var lib MySQL, as a normal directory, but Docker is transparently storing it in the persistent volume. This separation of data and application is what containers a practical way for stateful application. Now, once you start using volumes, you need to manage them. Now, before we start with the management, let's see how volumes are created and how it can be used. So I will just clear this screen and I would say Docker volume create my data. And if I go ahead and say enter, and you can see the name has been output, but the volume has been created. Let's see this on the Docker desktop. So when I go on Docker desktop and click on volumes, you can see my new volume has been created. What happens if I just say Docker volume create? See, now also the volume has been created. I have not given the name of the volume. See, it has given its default naming convention, which is actually not the correct way of defining it. That's why I was saying that you should use this. So let me go ahead and delete this specific volume. Now, what this command is doing is it is going ahead and creating an empty volume. See, the size of that volume is 0 over here. Now, when you want, you can use this volume with a container. So for using this volume with the container, what you will have to do is you will have to run this command. What this command is going to do is, so if I paste this command over here, let me show you. Docker run is going to go ahead and create a container for you. And inside that Docker run, what we are saying, the name of the container is MySQLDB. Then we are providing an environment variable. What is that environment variable? We are setting the MySQL root password for the admin user that we have, so that once it is created, we can go ahead and log in and perform the SQL command inside the container. Then we are going ahead and we are going to associate our my data with this. So when I do this association, at that time, what will happen? It is going to go ahead and create a Docker container which is going to be associated with the my data. So now if I go ahead and hit enter, so see, now as it is building the container and the image is not present locally, it is going ahead to Docker Hub, downloading the image. Once the demo image downloading is completed, then based on that image download, it is going to go ahead and spin up the container for us. So it will take some amount of time, but I think, see, downloading your image, so everything is done. Now let's go back and see in, see right now, see this has become in use. So it has become green because now container is using it. And which container is using this? This is the container which is using it. So if I click on this container and if I click on inspect, over here also you can see if there is any volume which has been associated, and over here you can see this volume has been associated, and these are the details of that specific volume that we have associated. This is how you can go ahead and create. Now, once we have created the volumes, what's next? So we need to manage them. Now, to manage them, what you can do is, so when you want to list uh, the number of volumes which are already been created, you can use Docker volume ls. It will list all the volumes on your system, showing their names and drivers. So I will go ahead, clear the screen, and say Docker volumes ls. Okay, my bad, it should be Docker volume ls. And over here it is showing that locally on the local driver we have created a volume named my data. Now once we create the volume, as you work with Docker, you will accumulate many volumes. So this command helps you see what exists and what not. Then comes the another command, Docker volume inspect my data. This is this point. So Docker volume inspect my data. So this actually what it does is it gives you the detailed information about the specific volume. Most importantly, it shows the mount point, the actual location on your host file system where the Docker stores the volume data. And on Linux, this is typically in the slash format, but for Windows, it would be different. So right now we are using Windows. So let's see how it looks for us. So I would say Docker volume inspect my data. Now this is one way of checking it from the terminal, but if you want, I already showed you the another way where you can just click on the sorry, you can go ahead and click on the volume. Once you click on the volume over here, you can see all the details of the volume which is available. Export, container is in use, association, everything is available over here. Now let's go back to the terminal, and over here I would say Docker volume inspect my data, and when I hit on enter, see it is giving me all the details when it was created, it is stored locally, and where it is stored right now, it is where lib volumes my data under data, and the name of the volume and the scope is local. So this is how you can get detailed information about the volume using the inspect command. Now comes next is to remove a volume, what you should do. So to remove a volume, you can use Docker volume remove my data. And important note, you can only remove a volume if no containers are currently using it. And right now we have just created a container, so it is already been used. So to delete the volume, first we will have to stop the container or delete the container. Then we have to go ahead and perform the delete for this volume. So let's try that. So I will just clear the screen, and if I go to our containers, so this container is up and running. I will stop it. Now my container is stopped, and you can still see now the volume is not in use because my container is stopped. So now let's go ahead and run the command Docker volume remove my data, and I will hit on enter. Error response. So it is still showing in use. The reason for that is still it is associated with the container. So what I will do, I will go ahead and say I will delete the container forever. Now once my container is deleted, now I will go ahead and run this command, and my volume has been successfully deleted. You can see it over here. You can see in the Docker Hub, or you can use the command Docker volume ls. See, it has disappeared. So this is how you can remove the container. Now you need, suppose if a container is using the volume, even at stop, the removal fails, as we already see. So you need to remove the container first. Not only stop it, you have to delete that container too. And over the time, you will have orphaned volumes, volumes that were created back a longer time, but no containers are using it. So these unused volumes, what we should do with them? So we can use Docker volume prone. So it is your cleanup command. It removes all the unused volume, freeing up your disk space. But you have to be careful through pruning. When you perform the pruning, it is going to permanently delete those volume. And if you have data in unused volume that you might need later, so first you will have to back up them, then you can go ahead and delete them. And regular volume management prevents your Docker host from filling up with abandoned data, which is not going to help you. Instead, it is going to cost you because of the storage it is going to have if you are hosting it on a cloud provider. Now, Docker supports two types of volume, named and anonymous. Let's understand the difference between them because it's important. So named volume has explicit name. So this is a named volume, right? My data. So I showed you when you are giving the name my data, it is going to be saved with my data. But when you're not going to give any name while creating the volume, it is going to use its hard-coded names which is available. Now, uh, another thing is named volumes that has explicit names. So by using explicit name, we have an opportunity to set the name by ourselves. Right now it is my data. We can keep it MySQL data. We can keep it application logs data, anything. So that is the beauty of using explicit names. And you specify them as volume name and the container path. So this is how you specify them, volume name and the container path when you have to associate them with the container. Now, named volumes are easy to work with because you can reference them by the name in commands. And it is very good for documentation too. So if you have any random name, it is really going to be difficult to document them. And if don't, it does not have a semantic naming convention or some kind of naming convention that your team follows, it is going to be difficult for the team also to work on it. Now, they are usable. Multiple containers can mount the same named volume. They are also identifiable. When you run Docker volume ls, you can see clear, meaningful names. So anonymous volume don't have explicit name. You specify them as just container path. So without a name. So right now, as we have a name, that is the reason we are associating both of them. But when you don't have a name at that time, what you will do? So you will just go ahead and say Docker run -v, that is volume, and directly the path. Now, when you do this, what happens? So Docker automatically generates a random name that we already saw. And anonymous volumes work, but they are harder to manage at the later time when you're working in the team. And when you see a random hash in Docker volume ls, you don't know what it's for. So you can't easily share it between containers because you don't know its naming convention. The best practice is clear. Always use named volumes for data you care about. Now, let's quickly cover bind mounts because they are incredibly useful for your development. Now, while volumes are managed by Docker, so when you create a volume saying Docker volume name, it is going to go ahead and create a volume for you, and it has been managed by Docker itself. But while volumes are created with bind mounts directly connect a specific directory of your local machine to a directory in the container. So the way in my previous slide, what we are doing is we created this volume, which is maintained by Docker. Then we are associating both of them. Now, instead of this, we have to give a path for our local system while you are creating the container and binding the volume with the specific path inside your container. And here's why developer loves bind mounts. You can edit code in your favorite editor on your laptop. and those changes immediately appear inside the running container. So no need of rebuilding the images, no need of copying the files. If your container is running, for example, a Node.js application with file watching enabled, it can automatically restart when it detects your code changes. This creates a seamless development experience. However, bind mounts have a downside. They depend on specific host path, and your Docker file might work on your Linux machine, but it is going to fail on your colleague's Windows machine because the file path convention for Windows and Linux is different. So for Linux, it is going to be forward slash, and for Windows, it is going to be a backward slash. And now when we are going to have that path inside our Docker file, it is going to create a problem. And they are also less isolated. Containers can access and potentially modify your host file system. For these reasons, bind mounts are great for development, but volumes are preferred for production. In development, use bind mounts for your code and named volumes for data like databases. This gives you the best of both worlds, where instant code updates and persistent data storage all work together hand in hand. Now let's see the complete practical example that demonstrate the power of volumes. We are going to create a new volume, number one. Then we are going to go ahead and run the MySQL container. Once the MySQL container is created, if you want, you can log in into the container and add some data. At the current moment, I'm not adding the data, but I'll show you the process. Then we are going to go ahead and stop the container with the command docker stop. Then we are going to remove that container, and then we are going to start another container, and then we are going to add that volume. This is going to show you that how you create volume once and reuse it multiple times. So let's get into it by jumping to our terminal. So over here, what is our first step? We are going to create a new volume. I will say docker create docker volume create my SQL data. New SQL data is created. I would say docker volume ls, and now you can see our volume has been created. Now what we are going to do next, now we are going to run a MySQL container. So for doing that, I will just go to the terminal, add this code over here. So over here you can see what I am saying is docker run the name of the container MySQL DB and the environment variable where I'm passing the secret, the password as secret, and then this is the name of the volume that I have created, and this is the path with which it is associated in the container, and this is the version of the MySQL. And when I hit on enter, it is going to go ahead and create a container. So it is now successfully created. Now the container is created. You can exec into that container by using IT and exec, and then you can make the changes or add data inside a database so that the volume would be loaded with data. Now, now assuming that the volume has been loaded with data, what we have to do is we have to move to step 4. So our step 4 is going to be stopping the container. So for that, what I would do, docker ps enter. Okay. So based on this, I actually got my container details. So now I will say docker stop mysql db mysql db. So you can use the docker and the container name that we have created, or you can use the container ID also for to perform the stop action. So now it will go ahead and stop. Now as our container has been stopped, the next step for us is going to remove that container. So for that, I will use docker remove mysql db. Now before I delete that, let me show you over here. So when I go to containers, you can see one container has been created associated with the image mysql version 8, and this is the container ID and the name of the container. Now when I'm going to go ahead and run this, enter, this has removed the container, and over here you can see the container has disappeared. Now once we do that, what is our next step? Now is the final step where we are going to understand how the same volume can be mounted to multiple containers. So this is the beauty of persistent volume storage, where the data is persistent even though container is destroyed, updated, or a new version of container is created. So this is the MySQL version 1, and now we are going to create MySQL version 2 with the same volume. So for doing that, what I will have to do is I will again have to uh, go to my command prompt, and this time, as we already have our Docker volume created that is available locally, we are just going to run this command, where this is the new container MySQL DB version 2, and the same things we have added, that is the volume and the path of the container. And now if I hit on enter, now you can see the same volume which was used in our previous one has now been mounted to the second one. Let's understand the networking challenge. By design, containers are isolated. Each container has its own network namespace, which means its own network interface, IP address, and routing table. The isolation is great for security, but it creates a problem. How do containers communicate? Imagine have a web application container that needs to connect to a database container. Without networking configuration, they can't even see each other. Or your application needs to call an external API on the internet. How does it get out and talk to the internet? Or when users want to access your web application, how do they reach a container that is a running container on your server? So these are the three fundamental networking challenges. That is the outbound connectivity to internet, container to container communication, and inbound access from external clients. Fortunately, Docker has built-in networking solutions that can handle all of these elegantly. Docker automatically creates network, assign IP addresses, manage DNS resolution between containers, and handles port mapping for external access. Understanding this networking concept is crucial because almost every real-world application involves multiple containers communicating between each other and with the outside world. So let's explore how Docker networking works. Docker provides several networking drivers, but we will focus on the three most important ones. First is bridge, the default network. When you run a container without specifying a network, it connects to a Docker's default bridge network. Containers are on the same bridge network and can communicate with each other using IP addresses, and Docker handles the routing traffic out to the internet. Bridge networks provide isolation from the host network, which is good for security. Second comes is the host networking. With host mode, the container does get its own network namespace. It directly uses the host machine's network. So for host, you don't have to create a namespace. Uh, it is going to use your host, that is the local machines network. This means if the container is listening on port 80, it's directly listening on the host port 80, that is your local machine port 80, not an isolated network or container port. So host networking has the highest performance because there is no network isolation, but it sacrifices isolation for you. Third and most useful are custom bridge networks. These are bridge networks that you create yourself. The key advantage is Docker provides automatic DNS resolution, so containers can reach each other by name, not just IP addresses. And this is essential for real world application to communicate between each other. So there are other network types also, like overlay for Docker Swarm, clusters, and Mac VLAN for advanced scenarios. But for most application, you will use bridge or custom bridge networks. So let's explore each one of them in detail. Let's start with default bridge network, which Docker creates automatically. When you run a container without specifying a network, it connects to the default bridge. Each container gets its own IP address, typically from the range of 172.17.0.x, which keeps on changing. And Docker sets up routing so containers can access the internet through the host machine. However, for external clients to access a container, you must explicitly map the port using the P flag that I have already shown you. That is host to container mapping, right? Now, for example, if you want to run two containers, a web server and a database, they are both on default bridge and can technically communicate using their IP addresses. Because for both of them, you're not mentioning any network over here. So if I run both of this command two containers are going to get created. So there is, by default, they're on bridge, so they can communicate between each other using the IP addresses. But here is the major limitation of default bridge. There is no automatic DNS resolution. If your web container wants to connect to database, you just you just can't use DB as the host name. You would need to know the database container's IP address. This is why the default bridge is fine for simple single container scenarios, but not ideal for application with multiple containers that need to communicate between each other because of this limitation. For those scenarios, you will want to use custom networks, which we will cover in the upcoming slides. The default bridge works, but as we saw, it's limited. Think of it as a basic networking that gets you started immediately, but not what you would use in the production when you're working for an enterprise. If you just want to run a single container, it is good to run it on the bridge network. But when you want to have multiple containers, right now I just have two. Suppose if you have 10, it is going to be a problem and headache for you. Now, let's talk about the custom bridge network, which I said is the most powerful one. So these are the solutions to the default bridge limitation that we just saw, and they are the best practice for multi-container application. Creating a custom network is very simple. To create a custom network, you say Docker network create and the custom network name. If you mention this name will come. If you don't, it will give its default name, which is not a best practice. So this is how you create your network. So this creates a bridge network that you can manage. Now, when you run containers and specify this as a network flag, so that container will become the part of this network. So over here, I am running the container that is MySQL and Nginx. So for MySQL also, I have given the same network, and for another one also, I have given the same network. Now, here's where it gets powerful. Containers on the same custom network can communicate using the container names as host names. So it actually removes the limitation that we were having in the automatic bridge networks that gets for which the containers get aligned when you're not defining any network. Now, over here, what you can see is your web application can connect to the database using DB as the host name, not an IP address. So Docker built-in DNS server automatically resolves DB to the database container's IP address, and this is huge for practical application. For application configuration, it is going to use MyDB 3306, which is the connection port as a database connection string, right? So even if the database container restarts and get a new IP address, the name DB is still going to work. The problem with our previous one was when we are trying, so right now it is we are communicating between both of them with IP addresses, right? So when I'm going to change or restart this container, the IP address will change. At that time, it creates a problem because every time you have to fetch the new IP address. But now, as the DNS resolution is going to work over here, you are not going to communicate between both of them by using the IP address. Instead of that, you are going to use the host name, which is automatically going to resolve the IP address for you. Now, custom networks also provide better isolation. Containers on different custom networks can't communicate with it unless you explicitly connect them. So right now, these both are part of this network. But if someone else want to connect to this network, you have to explicitly add them to this network. They cannot automatically spoof in on this network that you have created. And this is perfect for production environments where you might have multiple applications on one host, each with their own network interfaces. So custom bridge networks combines ease of use with proper isolation and the standard that is required for Docker applications in your enterprise. Now, we will talk about host network. So host network mode is fundamentally different from bridge networks that we saw. The previous two were bridge networks. But now, when you run a container with hyphen network host, it does not get its own network namespaces. It directly uses the host machine network stack. This means if your container starts with the web server on port 80, it's listening directly on the host port 80, not on an isolated container port. So, for example, when you are defining a Docker file, and inside the Docker file, you have explicitly mentioned that you're going to talk to the container with port 3000. Okay. Then when you run the container, you map the host port with the container port. But with this host network, you cannot do that. by default it is going to use the same network. So if it is 80 for host, then it is going to be 80 for the container too. This means both are going to be identical, and there is no port mapping needed and no NAT translation happening. The primary advantage is performance. Since there is no network translation layer, host networking has the absolute best performance. This is useful for performance critical application or network monitoring tools that need raw access to network interfaces. However, host networking sacrifices the isolation that makes containers very powerful. You can't run multiple containers that all want to listen on port 80 because already that port is going to be in use, right? So port conflicts become your problem because at one time only one container, one-to-one mapping. Also, host networking works on Linux host. It does not work the same way on the Docker desktop for Mac or Windows. So in practice, you will rarely use host networking. It's a specialized tool for specific scenarios where you absolutely need maximum network performance or direct host network access. For most application, bridge networks provide the right balance of isolation as well as the functionality. Now, let's cover the essential commands for Docker network. So the essential commands would be Docker network ls. So right now we have not created any network. So what I would do, I can go ahead and create one network for us. So I'll jump to the terminal and I will show you each and every command one by one. So, okay. So I would say Docker network create app, Docker network create doc, Docker app network. So this is the custom network that I am creating. You can custom bridge network, right? So I will hit on enter. Now our network is created. Now let's get back to our slide and see all the commands. How you can go ahead and list all the available networks which is available. So I would say Docker network ls. This is going to show you the list of network which are already available. So these are the list of networks available: bridge, Docker app network, host, and none. I created this one so that you can have a flavor of all of them. So these are the current ones. So three of them I have not created, it is by default, but one of them I have created right in front of you. Now, uh, it is going to list all the networks on your system and you will see the default bridge that is available over here. This is the default bridge, then a host, and then none networks that Docker creates plus any custom network that we have created, which is Docker app network. Then comes the second command. And what is that? Our second command is inspect network details. It shows the connected containers, IP addresses, IP address ranges, and the driver information. So let's go ahead and see what information it shows. So I would say Docker inspect, so Docker network inspect and Docker app network. So this is the detailed information that you are getting. So this command shows the network name. See the network name, then it is going to go ahead and give you the ID, driver name, and the scope. So it is going to give you detailed information about specific network, the IP address ranges it uses, subnet configuration, gateway, which containers are used or connected to it. So this is invaluable for troubleshooting and connectivity issue purposes. Sometimes you need to connect to a running container. So at that time also you can do inspect and get the details of that specific running container before connecting to that. So this is a very useful command that you might use in your scripting as well as in your day-to-day task when you want to get some information about existing container. Now, next one is connect running container to a network. Suppose I am running my web application on XYZ network. But recently, as you said, as you saw, I have created a new network, Docker app, and I want that container to be part of that network so that it can communicate with my database. So in that case, what I can do is I can go ahead and I can run this command Docker network connect, and I will give the uh, network that we have created along with the container name. So right now I'm not running any container, so I cannot associate, but this is how you can associate your container to a existing network. And the same way you can connect, you can also disconnect a running container by using disconnect command over here. And now if you want to remove the existing network, at that time what you can do is you can say docker network remove. So right now, as we have created, so first I will list the networks as we have created our own network. So let's go ahead and try to remove it. I will copy this. I will say docker network remove and our network name. I will say enter. And now if I run the command once again, you can see from 4 it has become 3 because our custom network has been removed, and these are the default network which docker has created by itself. So this is how you can use uh, in practice this commands. So for ls, docker network ls, to see what networks exist on your machine. Second is inspect to troubleshoot issues, and third is connect, that is occasional, that you might be using to adjust the running containers. And at the end is remove network, which you would use rarely because in enterprise you won't get the need of removing an existing network. Now, let's see a practical multi-container example in which, in this example, first we'll create a custom network. Then I'm going to run a database on this network, that is app network. Once we create this database, then I'm going to go ahead and run another database, another application on the same network. So this is how you can see that how you can bring in multiple containers onto a same network so that their connectivity is seamless. But the catch over here is this line. I will explain you step by step when I'm going to go ahead and do this with you right now. So I am on the screen. So this is the common Docker networking scenario where first we are going to create the network as we saw. So I will use the previous command, that is Docker network create, and the network that we are creating, the name is app network, and I hit on enter. Now let's see if it is created successfully. Docker network ls, yes, it is created successfully. Now let's clear the screen. Now this will be the communication channel between our containers. Next, we are going to run a Postgres SQL database container on this network, and we are going to give a clear name, PostgresDB, and set the required password by with the help of the environment variable that I will show you. So crucially, we don't need to expose any port because the database doesn't need any external access, only the web app that we are going to create at the end. So let me go ahead and now run this command. That is, we are going to create a database on this network, and see, as part of environment variable, we are sharing the password for the Postgres DB that we are creating. So as part of this command, what we have mentioned, docker run -d, that is, this container is going to run in the detach mode. The name of the container is going to be PostgresDB. Then the network to which it is going to get associated, that is our app network we just created. And then we are passing an environment variable with -e, and this environment variable is setting the password for us, by using which we can log in into the SQL database, which is going to get installed inside this Postgres DB. Now I will just go ahead and say enter. So see, the image is not available locally, so it is getting the image from Docker Hub. Once the image has been downloaded, that is 115 MB, it is going to go ahead and run the container. So the container is successfully completed. Now what I can do is I can show you on the Docker desktop. Yes. So if I click on containers, you can see PostgresDB container, it's running. And this is from last 13 seconds, it's up and running. Now, what we're going to do is then we are going to run our web application container also on the app network so that we can map port 8080 of the host to the port 80 in the container, so external users can access our web application and yeah, access our web application. So most importantly, over here what we are doing is we are going ahead and setting the database URL environment variable, that is this is the most important one. So As part of this, what we are doing is we are setting this saying uh, database URL PostgresDB 5432. Notice we are using the container name PostgresDB as the host name because we are using a custom bridge network over here and we don't have to provide the IP address. We can directly use the host name. So Docker's DNS automatically resolves this to the database container's IP address. The web application would now be able to successfully connect to the database, and external users accessing the web page can also do that by using localhost 8080, but the database remains isolated and unexposed. So the external user who is going to connect as part of this network, they are going to connect to this and they are not never going to go into our database. So they are only having connectivity with our front end, that is the web application, not the back end. So this is how we have created our architecture. Now it's time for us to clear the screen. So over here, what I'm doing is I am running a command docker run -d detached mode. Name of the container is web app, the network that we created, and here is the port mapping. So 8080 is our local machine post, and 80 is the container port. So we are mapping the host and container port. Then we are passing the database URL as part of the environment variable. So now I will go ahead and hit enter to create our web application uh, Docker container. And now, if I go back to our Docker desktop, click on containers, and you can see our web app container is successfully created with our existing previous image. And if I click on this, this has brought me to this page, which shows our application is up and running. And now, if we want, we can also associate our PostgreSQL is also associated with it. So external users can now access the web app through localhost 8080, but the database remains isolated and unexposed. And this architecture is secure. The database isn't accessible from outside, only from containers on the same network. This pattern scales to complex application like front end, back end, database, cache, all on custom networks communicating by name with each other. And this is how you build real world Docker application.
Let's understand the problem Docker Compose solves. Imagine you are building a typical web application where you need a database like MySQL, a cache like Redis, and your web application. So without Docker Compose, you would start by creating a network first by using this network command, right? So containers can communicate. Then you would go ahead and run the database with long command specifying the network, the volume, mapping, and everything, right? Then next you would start the Redis on the same network, and finally you would run the web application as the command. So each command is long and complex. You need to remember the exact order: database before the app, or the app crashes. If something fails, you are manually stopping and restarting the containers. Want to share this setups with your teammate? No, right? So to make it simplified, you will send them a text file with all these commands and hope they can run them correctly. This is tedious, error prone, and doesn't scale in an enterprise level work environment. So for a simple 3-tier container app, it's already complicated. Imagine application with 10 to 20 containers. So this is where Docker Compose comes into picture to escape you from these issues. It lets you define all of this container, network, volume, environment variables in a single readable YAML file. Then you manage everything with simple commands. Let's see how it really works. So first, let's talk about what is Docker Compose. So Docker Compose is a tool that sits on top of Docker, that makes managing multiple container application incredibly simple for you. So instead of running multiple Docker commands, you create one YAML configuration file called dockercompose.yaml. In this file, you declaratively describe your entire application, what containers you need, what images they use, which port to export, what environment variables to set, which volumes to mount, and how containers should connect with each other. Then with the single command docker compose up, you can uh, you can run, and Docker Compose reads your file and does everything: creating network, creating volume, pulling images if needed, starts container in the correct order, and handles dependency. The beauty is that it's declarative. You don't tell Docker Compose first do this, then do that. You just describe your desired state and Compose figure out how to achieve it. This makes the configuration reproducible. The same Docker compose.yaml file works identically on your laptop as well as on your colleague's machine or on a production server where you're going to deploy it. No more, it works on my machine issues. So usually people say it's working on my machine, it should work on yours too. So this actually eradicates that issue too. So Docker Compose transforms Docker from individual container management into application level orchestration. Now let's break down the Docker compose.yaml file structure. It's very simple. It looks complicated, but it's very simple. So the file starts with the version number. So this is the version number. This tells Docker Compose which syntax version you are using. So right now, the version number that I'm using is 3.8, which is the latest one. The most important section that you have to take care of is the services. So over here, you define each service as one container. In this example, if you see, we have two services, web and DB. Under each service, you specify their details. So for web service that you see over here, so for web, we use the nginx image and we map the port 8080 on the host port, on the container port 80. So host port is 8080 and the container is 80, and we have defined in the same way like we do in the commands. Now for database, we use mysql 8, set an environment variable for the root password and mount a volume for persistent data storage. Notice how much cleaner this is than the longer Docker run command that I was showing you in my previous slide. Everything is organized, easy to read. And here we are creating the DB data also as a volume that you can see. Okay, you can also have a network section if you want, where you can define your custom network. Though if you don't specify one, Docker is going to go ahead and create that as part of the bridge network as we discussed already. And each service can reach each other by service names. So web can connect to DB by using DB as the host name, thanks to the automatic DNS resolution as part of the Docker Compose. This YAML structure is intuitive. Indentation matters over here. Key value pairs should be clear, and it reads almost like documentation. Whenever you're creating this file, the only thing that you have to take care of is see the indentation over here. Right now it is not showing, but when I'm going to show you the real example that I have ready for you, see, this is the file that I was talking about, version. Now comes the service. Now under services, we have two services, web and DB. See the indentation. This indentation matters. Now, whatever arguments you have to provide inside web, it should again be indented inside it. Now for ports, if you are providing any entry, you have to indent that again. So you have to make sure that you take care of it properly. Now, the first important is version, then services to configure your container, and the supporting elements like volumes and networks you can define based on your requirement. Now let's learn the essential Docker Compose commands one by one. The most important is Docker Compose up. So when you go ahead and run Docker Compose up, what it is going to do is it is going to go ahead and read the Docker Compose file line by line. And over here, if you see services, that means it has to run two containers, it has to create volume, it has to create network. It is going to do everything one by one, and while you are running it, you can see it on the console itself. So I will go ahead and show you. Now Docker Compose up command is single-handedly okay when you have only one Docker Compose file in your current directory, but if you have multiple files, at that time you have to use -f command where you mention the file name. So as you can see, I have two examples for you. One is this and the one is this. So by chance, if I just say Docker Compose up, it is going to pick this one, but I'm going to use this one. So let me go ahead and show you how it is going to go ahead and build the images with this command. I would say Docker Compose the file, and the file name is Docker Compose x.yaml. So after mentioning the file name, the last and the important one is you will say up. It is going to bring up all the services for us. So I will hit on enter and you will see it has started working. So it is showing that the image is not available that it is trying to build. So it is pulling it from the Docker Hub. See, pulling. So once the pulling image is completed, it will show you that which steps it is going to run. So right now you can see this is the DB. that it is right now, see, pulling over here. It is showing you, and this is the web. So these are the two services that it is going ahead and doing. See, this is done. So it has check marked. Now it went ahead and it created the network, it created the volume, and it also shows us the containers that were created successfully. And this is how Docker Compose goes ahead and create everything. And you can see how it is running at the current moment. So this will keep on showing content over here, because right now I am not using the detached mode that is running in the background. Right now it is running in the foreground. Now what we can do is, now we can go to our Docker containers over here. What I can do, see, if I click on this, as part of the Docker Compose, you can see two containers has been created, db1 and web1. And see, this is MySQL 8, the same image MySQL 8 that we have used. See, this is the containers, two containers which have came up. Along with that, you will also see the database as we have used. So it has downloaded the images, web image, as well as the MySQL image for us. Everything just by running one file instead of running multiple container run commands. Now, once you are doing this, so it is going to be difficult to go ahead and stop this if you are doing it in the foreground, or you will have to open another terminal. But for now, what I will do, I will just say Control C over here, and it is going ahead and stopping the containers. So if I go back, now you can see the containers are exited, but it is not deleted, correct? So when you exit like this way, this is going to stop or both the containers. But once you made some changes and you want to, suppose you added a new service or you added a new container, so you can again go ahead and click on up, and it is going to add that specific service to it. But if you want to clean everything, you can use the same command, and this time I will just say Docker Compose down. Now see the magic. And once I hit on enter, what exactly it is going to do for us? So when we do Docker Compose down, it stops as well as removes the container and the network, but it is not going to remove the volumes. Volumes are preserved so that our data is persistent. So that is the beauty of Docker Compose down. So if I go ahead and say Docker Compose down, see, it has started. So it says me that I have removed both the containers as well as the network. Now let's go back over here. See, all the containers have disappeared. If I go to volumes, the volume of MySQL data is my app DB that I have created. Let me show you. See, uh, the volume DB data is available over here, DB data. So the persistent storage is available, but the other things, that is networks and uh, other components, have been successfully cleared. So that is the beauty of using Docker Compose down. Now, suppose if your Docker Compose is running, if I again go ahead and clear the screen, and this time I am going to say Docker Compose up, and this time it is going to be in the detached mode. So now it is running in the background. Okay. So now if I say Docker Compose PS, see, it is showing me uh, the Docker Compose which is running right now. So based on this, you can see as part of this Docker Compose what all apps are running, right? So that is how you can use Docker Compose PS, which is going to show you all the services which are running as part of your Docker Compose. Last but not the least, if you want to see Docker Compose logs, you can use Docker Compose logs, and it is going to show you the logs which are there, and it is going to show you the logs for the web as well as the DB. But now if you see, I just want to see the log for a specific service, that is a web server. So in that case, you just have to go ahead and use the same command, and at the end just say web. What is web? Web is your service name. Okay, you have to mention the service name. So I would say web, enter. See, now it is just showing web. Now if I clear this again, let's see what is our next service, DB. So this time we will say DB, and if I say DB, see, DB service logs are available over here. So that is how you can use the Docker Compose commands. Now let's examine a real world Docker Compose file for a complete application. So we have four services: web, API, DB, and cache. Let me show you first. Before I show you, let me go ahead and first clear this, and we will use Docker compose down, and so let it clear everything for us. Once it is clear, now we are good to go. So now it's time for us to see at a real level application example. So this is our real level application example. So over here we have four services. As you can see, we have the web service, the API service, the DB service, and the cache service. Now the web service use Nginx to serve the static files, and we map the port 8080, that is from the host to the container 80, and we mount a local directory for the HTML files and specify it's dependent on the API service. This means Docker Compose starts API before the web. So if I say depends on, then this service is not going to start till the time this service is up and running. So this is how you can create dependency between one service and the other, because if you are not going to use depends on, and it will first go ahead and create the web, but without API it might not be able to serve this, that in then in that case it is going to give you an error and your creation of services would fail. That's why it's very important for you to use depends on flag to add the dependencies. Now, the API service is, now we will come to the API service. In the API service, we have done something different. So in first, we have used the image, that is the ready-made image, that the way that we used in our Docker file. But now for the second one, we are going ahead and saying /API. So the API is built from a Docker file, that is / in the / directory. Rather than using a pre-built image, we are creating a custom image over here, and we set environment variables for database, cache connections using services names as host name. It depends on both database as well as the cache, ensuring they start first before this starts. Okay. Then comes the database service. The database service runs the PostgreSQL with environment variable for the password and the database name, and uses a named volume for the data persistent, as you can see over here. See the named volume. So we have done the mapping also. This is our created volume that you can see over here, Postgres data, and we have mapped it with the container path for PostgreSQL. Now the cache service that you see over here. So our cache service is running on Redis. Very nice and simple. Again, the ready-made image we are using, and notice we have just defined two networks over here, front end and the back end. The web and API services are on front end, while API, DB, and cache are on the back end. This creates network isolation. The web service can't directly access the database. It must go through the API to access the database. It cannot directly talk to the database. This is a security best practice, and the volume section declares Postgres data over here. See that we have used over here. Okay, so this is a security best practice, as I said you, and this compose file represents a complete production ready application architecture with proper segregation of concerns, dependency management, and network isolation. And we can start this entire stack by just running Docker compose up. So after watching the real-time example that we came through, it's time for us to see what's next. So next we are going to talk about how to build custom images with Compose. In our previous example, I gave you one information saying that you can build your custom images also in Docker Compose. Now let's speak in detail about that. So for services using existing images like Nginx, that you can see Nginx and Postgres that we have used for our database, you can simply specify the image name and the tag that it is holding, if you want the latest image name or any specific tag. And for and Compose is going to go ahead pull that from the Docker Hub for you. But for your own application, you want to build, you will build from a Docker file. So the simplest form is by using build over here. So when you want to build a Docker file, and when you say build dot, it is going to search the Docker file in your current directory. But if you want that, if your Docker file is located in some other directory inside your current directory, you can go ahead and give the path over there. So when this specific service API is going to run, it is going to search for Docker file over there. Then it is going to build that Docker file, and after building that Docker file only, it is going to create a container out of it. Now you don't need to manually run Docker build and tag the image. Compose is going to handle all of that for you. For more control, you can use the expanded syntax, and you can specify the build context directory also, which Docker file can use. Now, for example, If your API code is inside /API and you have a different Docker files for development and different Docker file for production, you could specify the context over here as /API and the Docker file name. So based on that, it is going to pick that. And when you run Docker compose up, compose checks if the images are needed to build that file and builds them automatically. Now, if you make change to that Docker file or the application code, then you can run Docker compose build or Docker compose build or Docker compose up build. What it is going to do is it is going to rebuild the image for you, which was used as part of that Docker file. And this integration between compose and building makes development workflows very smooth. Change code, rebuild, restart, all with simple commands. Now, managing configuration across environment is crucial, and Docker Compose provides several ways to handle this. You can set environment variables, okay, over here as part of your argument, that is environment. Okay, so your environment variables get directly integrated in your Docker compose.yaml file with the help of this argument. For example, setting the node environment to production, we have added that over here. Node environment is equal to production, and if you want, you can also pass the API key. So but hard coding sensitive values like API key is a bad practice. So instead you can reference environment variables from the host machine using the syntax. So whenever it is going to go ahead and check the API key from your host environment, which is there on your local machine, and then it is going to use it. It is not going to store it anywhere. And when compose starts, it substitutes that value from your environment over here. Even better, Docker Compose automatically loads a .env file. That is the second option if it exists in the same directory as your Docker Compose YAML. And this file contains the key value pairs like API key, and you can keep this file out of version control for security. So if you suppose this is my current, this is my root folder, right? In my root folder, if I go ahead and have a .env file, it becomes very easy for Docker Compose to read from that existing file. And over here, what you can do, you can store your credentials locally. See, it is saying API key. This is my API key and this is my database password. So it is not going to be pushed on GitHub, or it is not going to be exposed anywhere. It is going to be on your machine only. Now, each developer has their own way of environment file with their credentials, and production servers have their own way. So for different environments like development, staging, and production, you can use multiple compose files. The base compose.yaml file contains common configuration. Then you can create docker compose.yaml file. So right now I have just created docker compose.yaml file, but based on your environment, suppose right now I am running on development environment. So I would say docker compose dash dev.yaml file. And when I want it for another one, that is a production environment, so I would say docker compose prod.environment file. So in this way, what I can do is I can go ahead and I can segregate the Docker Compose environment based on the different section of application in which my applications are distributed, that is dev, prod, and staging. Now, the base compose.yaml file contains the common configuration, and the others are going to have production configuration. When running, specify multiple files with F flags. So right now, if I have used F flag, I have used this file, but along with this, if you want to run multiple docker.yaml files, you can again use f docker.yaml. And if you want to add few more, you can also do that. So compose merges the files with later files, overriding the earlier ones. This pattern keeps your configuration dry. Don't repeat yourself while allowing environment specific customization. It's how professionals make Docker application across development. So let's start by understanding why configuration management really matters. Every real application needs configuration. Database connection strings to know where to connect, API keys to authenticate with external services, service URLs that differ between development and production, feature flags to enable or disable features, and password or credentials for authentication. So these are the basic five things. At least this you are going to get in every real-time application. The wrong way to handle this is hard coding the values directly in your code. Imagine you hard coded your production database password in your application code, and now that password is in your Git repository forever, visible to anyone who is going to access that Git repository. Even if you delete it later, it's still going to be there in Git history. So if you use the same configuration for all environments, your development database might accidentally connect to production, which is going to be a disaster. So the right approach is to externalize configuration, uh, meaning keep it separate from your code. Use different configurations for different environments. Development uses dev database credentials, production uses production credentials, and critically handle sensitive data securely, never exposing it to the outer world unnecessarily. Docker provides mechanism for this through environment variables and Docker secrets. So environment variables are the standard way to pass configuration to containers, making your application flexible and environment agnostic. Let's explore how to use them effectively and securely. So Docker provides three main ways to set your environment variables in containers. First, you use the -e flag to run it with Docker run, where you specify the variable name and the value. Like you can see over here, this is the variable name and this is the value. So you can use multiple e flags to set multiple variables within one single commands. And this is simple, but it gets unwindingly uh, big with many variables. Imagine you are typing 10 to 15 flags inside this specific command. How long that command is going to be? It is going to be uh, not readable properly. Then second, using an environment variable with .env file. Now, what is this .env file? This is a very simple way, and actually in enterprise we use it. I have worked for all the clients, and this is the basic practice that they use. The second one for sure. So if I take you to our Docker Compose, okay. So in my Docker Compose, what I have, so before that, let me tell you. So this is my environment.env file. So your .env file is supposed to be in the root directory of your application. Over here, what it is going to do is it is going to go ahead. You can go ahead and describe the username and password, API keys, whatever data that you don't want to push to Git or to the external world. It has to be local on your machine. So in this case, you can have your credentials defined in this way. So right now I have defined my credentials for dev, UAT, and prod. So this segregation also helps me when I'm going to use it. So for example, now if I want to use devdb user, so while I am going to create my database over here, when I have to pass the username as part of environment variables, I am just going to say dollar and the name as, oh sorry, I'm just going to say dollar and I'm going to go ahead and paste this. So I will just paste it here and you can see devdb user. So based on my requirement, I can use those variables and I can pass that into the code. So whenever Docker is going to go ahead and run this, so Docker is going to get this dollar value from the .environment file, which is there in your local environment. So this is how you can actually save your credentials on your local machine. And the second challenge would be if you are saving it here, when you're going to perform a push to Git, it would go to Git. No, it won't, because you have to also go ahead and mention this .env and whatever. Suppose if I have made .env and in this I have done dev, UAT, and prod, but many people make it separately, env, dev, env, UAT, like that. So I have already ignored this file. So as part of the Docker build, it is not going to go in the context itself. And as part of the git ignore also, I have added this file. So it is not going to be pushed on my Git. So this is the practice that actually enterprise really follow, that I have witnessed. Third, you can set the default variables in your Docker file using the env instruction, like the variable name and the value. But this become part of image uh, and set of the containers created from that image. And this is good for non-sensitive default variable pairs only. So for example, when you're defining port, this is non-sensitive. When you are defining the environment, it is non-sensitive. So inside the container, your application reads this environment variable just like it would read on a regular system. But it is not a good practice to use the database username and password like this when you are using it, okay, in your Docker file. So better, what you can do is you can actually go ahead and use the environment variable. Now next we are going to talk about environment variables in Docker Compose. Okay, Our last video we have discussed a lot, but now let's see one more example for it. In your Docker Compose .yaml file, each service can have an environment section where you define the variables. So if I take you to our previous example, so right now, see, each service of mine, apart from the web, the API, the database, see, both of these service are having environment. If I want, I can add it over here also. In each service, you can go ahead and add and define your variables. Like, for example, you can use the list of variables like node environment is equal to production, or map the format with a key value pair that is like this. See, this is key and this is value with colon. Either you do it with is equal to, or either you do it with colon. So now when you are doing it with is equal to, you have to use dash, and when you're doing that in key value pair, you have to define it in this way. So this is what you have to keep in mind. Uh, however you don't want to hardcode sensitive values like password in Docker Compose .yaml file again, especially if you are committing it to Git. So instead you can again use the substitution variable over here. Substitution variable means, so we are going to create a .env file, and from there I am going to get this value. So over here you can see again I have used dollar API key. So what I will do, I will go ahead and just define my API key as part of this env file. So it is going to go ahead and pick that from my env file itself. So here is the critical security lesson. Every variable are not secure for sensitive data. And this is a common misconception. Let me explain why. First, anyone with access to Docker daemon can run Docker inspect on your container and see all the environment variables, including passwords and API keys. Second, environment variables can appear in logs. If your application logs its configuration or an error, it includes environment context, and the secrets might leak from there too. Third is the environment variables are inherited by the child processes. So if your application spawns other processes, they all see the secrets. And fourth, if an application crashes and generates an error report, environment variables might be included there also. Fifth, if you set environment variables in Dockerfile using env, they are baked into the image layer, and anyone who has the image can extract them. This doesn't mean environment variables are useless. They are perfectly fine for non-sensitive configuration. So as I said, when you are using this env like this for these kinds of non-sensitive things, it is okay. But for this username and password, you should not use it. Now, sorry, you should not use it. But for truly sensitive data like database password, API key, private secrets, encryption key, environment, these aren't alone secure by using .env file. So for production system handling real sensitive data, you need Docker secrets or external secret management that I am going to talk with you now. So now uh, let's talk about practical strategies for managing secrets in real projects. Now we have moved one step ahead of .env, because many a times that .env can also leak the data. Now for development, .env files work great. So right now, whatever I have showed you for .env, it is good for developer. Each developer has its own .env file with development credentials, and the file is listed in .git ignore, so it is never committed to Git also. For non-sensitive configuration, regular environment variables are fine. As I already said, like for port number, there is no need to put that into specialized secure management. Now, you can even use mock or fake credentials for local development. A local test database doesn't need a strong password. For production, the approach depends on your infrastructure. If you are on AWS, you can use AWS Secrets Manager or Parameter Store. If you are on Azure, you can use Azure Key Vault, where you can save your sensitive credentials. That is better than having that in environment file, specifically for your production environment. I'm not talking about development, for production. Third, if you are on Google Cloud, again, Google Cloud also have a secret manager. You can use that. And this services encrypt secrets, control access, and provide audit logs and integrate with containers. So providing audit log means what? So who has actually gone ahead and accessed this data that is there in their credential stores, that also can be audited. It is that advanced. And for advanced need across multiple platforms, you can also use HashiCorp Vault. It is a powerful solution. Regardless of the system, follow these general rules that might help you. So always add .env to your .gitignore and use completely different secrets for each environment, so a compromised dev secret doesn't affect your production. What I mean by that, so if you see, my dev, UAT, and production secrets are different. Many times people keep all three of them different. They have added all the security over here, and if this leaks, everything leaks. So what is the meaning of adding an extra layer of security for here when you have not followed the best practice of changing the username and password different for every different environments? So that is one of the best practice you should follow. Next, give each service only the secrets it absolutely needs. Don't give every container access to every secret. Many a times, if you are using a container, suppose if I am using a web container, why it would require the access to the credentials of database, right? So I should not give that access to that specific container if it's trying to access, or the worker node which is trying to access it. Instead, I can have those server only which is having the database installed on it. And these practices protect your application and data significantly in real time. Now let's see complete production ready example of secure configuration. So we have two files. One is .env file and a Docker Compose file. Now the .env file over here contains the actual secret values, database password, API key, Redis password, and this file is not committed to Git as it's added in .gitignore. So each environment has its own .env file with appropriate secrets. And the Docker Compose file is committed to Git because it doesn't contain actual secrets. It only contains the variable references like database password over here, Redis password, database password, whatever we have mentioned, API keys. So this file documents what configuration the application needs without exposing the value. Notice in web service, we are building connection strings that include these secrets. The database service uses the password from the environment. Redis is configured to require authentication using the password. Okay, so Redis is also is going to require the Redis password to get authenticated. Now a new developer joining your team clones the repository, creates their own .env file with development credentials based on the template you have provided, and everything is going to work. In production, you create a .env file with production credentials, deploy the same Docker Compose file, and the application runs with your production config also. This pattern is clean, secure, and widely adopted. So same config file, and on every environment, this file is going to be different. One file for dev is going to have this credential, UAT will have another credential, and prod will have other credentials. So you're just going to push this file, and those credentials which are already configured for prod file, based on that only it is going to pull the password, and it is going to create the same infrastructure that you're creating on your dev environment. This pattern is clean, secure, and widely adopted. It separates code from configuration, keeps secret out of version control, and makes environment management straightforward. And still in today's enterprise, many of them use this approach. Let's understand the production reliability problem. When you run Docker PS, you see if the container is up or exited. But up only means the container process is running. It doesn't mean your application inside that container is actually working correctly. Imagine a database container that's up but crashes internally and isn't accepting any connections, or a web server that's running but deadlocked and returning 500 errors to all the users who are trying to connect to your web server. The container technically didn't crash over here, so Docker thinks everything is working fine, but your users can't use the service. This is a critical gap between container status and the application health. In development, you might notice issues quickly and manually restart the containers. But in production, with potentially hundreds of containers running, you can't manually monitor and restart everything. You need automation. This is where health checks and restart policies comes into picture. Health checks actively verify that your application is functioning correctly, not just that the container is up and running. Restart policy tells Docker what to do when the container fails or stops. Should it restart them automatically? And if it restarts them automatically, how many times it should restart? This feature transforms Docker from a container runtime into a reliable production platform. Without them, you are flying blind and manually fighting fires. With them, your containers are self-healing and resilient. Docker provides 4 restart policies that control what happens when the containers stop. The default policy that you see over here is restart is equal to no, meaning Docker never automatically restarts the container. If it crashes or exits, it stays stopped until you manually restart it. This is fine for your development servers, but it is not good for your production servers. The second one is restart is equal to on failure policy. So this policy restarts the container only if it exits with a non-zero exit code. That is indicating an error. If your application crashes due to a bug, Docker restarts it automatically. But if you manually stop the container with Docker stop command, it stays stopped because that's a clean shutdown with exit code 0. When you're going to do Docker stop, the Docker name or ID, it is going to stop gracefully. So it is going to return the exit code as 0. But if it crashes, at that time it is going to return the exit code as 1. Now, the third one is the always policy. It's more aggressive. Docker restarts a container regardless of the exit code, whether it is 0 or 1, even if you manually stopped it by using Docker stop command. Moreover, when the Docker daemon starts, containers with the always policies are automatically started. This ensures your services come back after system maintenance or unexpected reboots. Finally, the last one is the unless stopped. So unless stopped is very similar to always, but one key difference over here is if you explicitly stop a container using a Docker stop command, it stays stopped even after daemon is been restarted. This gives you manual override capability while still providing automatic recovery from the crashes. For production, you will typically use the second one, that is always, or the last one, that is unless stopped, for critical services. These policies make your containers resilient to crashes, server reboots, and other failures without manual intervention. So in Docker Compose, restart policies are even easier to configure, as you can see over here. So let's break it down. Under each service, you can add a restart key. So this is the restart key that I am talking about. See, under each service, under web service, I have restart key. DB service, I have restart key. Under cache service, I have a restart key. So you might use restart unless stopped for your database. So it respects manual stop during maintenance that you're performing on your database. For less critical services, you can use a restart on failure, which might be appropriate for Redis, that is for the cache that we are using. Now, Docker Compose also supports advanced restart configuration using the deploy section. You can set max attempt to limit how many times the Docker tries to restart a failing container. This prevents infinite restart loops if a container is fundamentally broken and it is again and again going to restart. So you can also set a delay that you can see over here inside deploy. We have delay over here. So you can also set, this is a delay between restart attempts, giving the system time to stabilize. For example, suppose if you spinned up your container, it might take around 10 to 20 seconds to come up. But if you have kept the delay less than that, it is again and again going to restart, and it is never going to restart because its warm up time itself is 10 to 20 seconds. So always set max attempt over here in the deploy policy. So uh, for services that might fail repeatedly. So for example, if your application crashes 10 times in a row, something is fundamentally wrong with your build that you have done. And infinite restart won't stop until you are giving a max attempt. So max attempt says that if it fails maximum 3 times, you will restart it. These policies should be critical for your initial Docker Compose setup. You should not add it later as an afterthought. They are essential for production reliability. Now let's understand health checks. So we just spoke about the restart policy. Now it is the health check. So health check is a command that Docker runs periodically to verify your application health is working correctly. Previously, we were verifying if the container is up and running with restart policy. Now we are verifying if the application inside that container is working properly. The command can be anything. It can be an HTTP request, a database query, a ping, whatever makes sense for you to understand that your application is up and running. Now, the command returns an exit code, which is 0 means it is healthy. Your application is performing well. Non-zero means it is unhealthy. Based on this, Docker updates the container's health status. You can define health checks in your Docker file using the health check instruction. So let's break down this syntax that you can add in your Docker file. So over here, we will start with interval is equal to 30 seconds. It means run the check after every 30 seconds. Next is timeout 3 seconds. Means if the command that you have run doesn't complete within 3 seconds, consider the command has failed. Now the retry means the container is only marked unhealthy after 3 consecutive failures. This prevents false alarm from temporary glitches. For a cache, that is the Redis that we saw in our last one, uh, you can use a ping command instead of using a curl command. So right now, when you run this curl -f http localhost, it tells you whether the application is healthy or not. So if it is healthy, it is going to go ahead and give 0. If not, it is going to exit at 1. So the key is choosing a check that actually verifies the functionality of your application, not just that the process is up and running. Health checks gives you visibility into your real application health, not just container status. They are the difference between knowing a container is running and knowing it's actually serving the request, that is the user request. So how you define that in Dockerfile, let me show you over here. So this is our Dockerfile that we have used in our previous video. I have just added this section over here. So now this is going to be embedded with our build itself. So this is going to be the health check which is going to be performed. Now in Docker Compose, health checks are defined in a service configuration. Service means, as you remember, we actually define each container as a service. So the test field specifies the command to run. So under health check, the first parameter that you see is the test. You can use a array format like cmd, curl, then you can use -f, and so these are multiple commands, right? And then http localhost or a shell format like cmd shell. So over here, you can see I have used one cmd, then another one I have used cmd shell. So this is an array where you can use multiple commands. Now, next comes the interval. The interval is how often to run the check. Then comes the timeout. The timeout is how long to wait for the command to run. Then comes retry. A retry is how many consecutive failures before making it unhealthy. Notice the start period setting over here. This is very crucial. It's a grace period during container startup before health check count towards the retry limit starts. As I said, sometimes a container warm-up time is 20 to 30 seconds. So if your application takes 30 seconds to initialize, you can set the start period to 40 seconds. So Docker don't prematurely mark it as unhealthy during the startup itself of the container. Now, let's talk about another example. So this was for web server that we were talking, web server service. Now we are going to talk about the Postgres. So for Postgres, we can use pg is ready. So pg is ready that you see over here, the cmd shell command that I have used, and I am passing the username, but you can also pass the username along with the password. So let's see an example over here. So if you go over here, so what I'm doing is I'm using pg is ready, and then based on our environment variable, I'm passing the username and password so it can log in and then it can perform that specific check that we are looking forward for. So it is a tool specifically designed to check if Postgres is accepting connections. This is better than just checking if the process of database is up and running. Each application type should have an appropriate health check. So the goal is to check that genuinely verifies the service is ready to handle request or not. Health check in Compose make your entire stack self-monitoring with every service reporting its actual health status. Now the real power comes from combining health checks with the restart policy. So now we are going to combine both of them. So look at this complete example now. Now over here, the API service has restart. So we are talking about this service. So it has a restart as unless stopped. So it automatically recovers from crashes. It also has a health check hitting a health uh, uh, and health check URL where it is going to hit the health to understand if the application is up and running. Docker marks it unhealthy if it is not up and running. So here's where it gets powerful. The API service uses depends on with condition service healthy. Now this is an advanced part. So what exactly is been done over here? So if you see, we have one more section depends on. So now we are saying that this service depends on the healthy status too. So we have added that as a parameter. So this means Docker waits for the database to not just start, but to become healthy before starting the API, which is going to serve the request to the database. This solves a common problem. Your API tries to connect to database before it's ready and crashes. With health conditions, startup is properly sequenced. Now, if the database becomes unhealthy later, you can configure orchestration to restart dependent services. This combination provides multiple layer of reliability, automatic restarts on crashes, continuous health monitoring, and intelligent startup sequencing. Your containers don't just start and hope for the best, they actively verify the functionality and recover from the problems automatically. So this is a production grade container management, that example that you see. You sleep better at night knowing your services are self-healing and you don't have to make the changes manually. Let's consolidate the production best practices now. So before consolidating the production best practices, I updated our Docker example that we have used in our previous video, Docker Compose. Over here, I am adding health checks for 4 different services. One is for web server. Over here, see, I am using HTTP localhost to see if the uh, service is, if it is really serving the traffic which is coming in. Then for API, I'm going ahead and checking the health parameter to see if the API is working. Then for database, I'm using the PG is ready to which is going to check if the data Postgres SQL is ready. And for the cache, we are using ping command. So as I said, for different services, we are going to use different commands. So for this command, we are using for this service, we are going to use ping command, which helps us to understand if the cache service is up and running. Now, for restart policies, always use always or unless stopped for critical production services. These ensure service come back after crashes and reboots. Set max attempt to prevent infinite restart loops. If a container fail 5 times in a quick succession, something is definitely wrong and something is broken and a manual intervention of a human is required. So monitor how often containers restart. Frequent restarts are a symptom of underlying problems that need fixing, not masking it with automatic restarts. For health checks, ensure they test actual functionality, that is the application functionality which is there inside your container. Don't just check if the port is open, verify the application responds correctly. If your app takes time to initialize database or load data, set an appropriate start period. As I showed you, we have set the start period as 40 seconds in our previous slide. So it's not marked unhealthy during the legitimate startup time that it is going to take. Keep health checks lightweight. They run every 10 to 30 seconds. So expensive operations would waste your resources and would incur extra cost. Many production apps implement a dedicated /health endpoint that returns 200 OK if healthy, making checks simple and fast. For monitoring, integrate Docker health checks with your monitoring systems like Prometheus, Grafana, or cloud monitoring tools. Alert when containers are stuck unhealthy. Health checks are only useful if someone knows there is a problem. If there is a problem, you should send an email notification, Teams chat notification to the support team. So you can do all this integration by using the health checks. So log restart events to understand patterns and root causes. So whatever is happening, make a knowledge base out of it. So you know what is the pattern, and based on that, you can have a recovery policy or a recovery plan that you already set for it that can be later automated. These practices transform Docker from a container platform into a reliable production infrastructure. Now, thank you for watching. This is the final video in our Docker Essential series. Congratulations, you have completed the entire series. You now understand Docker from ground up. If you enjoyed this video and this series and want to keep learning step by step, make sure to like the video, subscribe to the channel, and hit the bell icon so you don't miss the upcoming new series after this. Thanks for watching, and I will see you in the next series.